Begin as we have with the other sessions, I will turn this over to go around and introduce ourselves, and then we will have the conflict of interest statement. I'm Dave Eaton from the University of Washington. Chad?
I'm Chad Blystone, NTP NIHS.
Dave Malarkey, NTP NIHS.
Michael Wide, NIEHS NTP.
Mark Sesta, NTP NIHS.
Keith Shockley, NIEHS.
Christine Witt, NIEHS NTP.
Wolfgang Kaufmann, Retiree Director, Pathology at Merck.
Susan Felter, Procter & Gamble.
Rick Adler, I work for GlaxoSmithKline.
Frank Barnes, University of Colorado.
James Lin from the University of Illinois, Chicago.
Mark Klein, Wake Forest School of Medicine.
Larry Whiteley, Pfizer.
Matthias Rinke, retiree, formerly Bayer AG.
Kamala Pant, BioReliance, Millipore Sigma.
Jack Harkema, Michigan State University.
George Corcoran, Wayne State University.
Lydia Andrews-Jones, Allergan.
Tyler Malice, Data Management Services.
Mary Wolf, NIHS NTP, Designated Federal Official.
John Bucher, NIHS NTP.
Galen Kepke, NIST.
Edmund Ply, FCC. Gonçalo Gamboa, FDA Liaison Officer to the NTP.
Edmond Jerison, Food and Drug Administration.
Kelly Shipkowski, ICF. Candon Bird, ICF.
Jeannie Liu, ICF.
Carl Blackman, Wake Forest Medical Center.
Don Stump, Charles River Labs, and representative of the NTP Board of Scientific Counselors.
Gabrielle Wilson, Experimental Pathology Laboratories.
Tom Steinbach, EPL.
Russell Owen, US EPA.
Ron Melnick, retired, NTP, NIEHS.
Peter Little, EPL.
June Donick, NIEHS NTP.
Darlene Dixon, NIEHS NTP.
Sheila Churchill, Charles River Labs, contractor for NCP.
Hiroaki Miyagi, consultant.
Miles Capstick, ITIS Foundation, Zurich.
Niels Kuster, ETH Zurich, ITIS Foundation.
John Madbury, NIST RF Fields Group.
Amy Briggs, contractor for NTP NIEHS.
Khyatanahalli Janardhan, Integrated Laboratory Systems.
Robert Sills, NTP NIEHS.
Maggie Grubel, EPL.
Joe Elder, retired EPA, retired Motorola consultant.
Susan Elmore, NTP NIEHS.
Mario Smith, Social and Scientific Systems.
Grace Kissling, retired from NIEHS NTP.
Cynthia Wilson, Integrated Laboratory Systems.
Angela King Herbert, NTP.
Molly Walland, NTP, NIEHS.
Nigel Walker, NIHS and the NTP.
Michelle Huth, NIEHS NTP.
Ruth Lund, NIEHS NTP.
Georgia Roberts, NTP, NIEHS.
Matt Stout, NTP.
Okay, thank you, everyone. This is just a reminder that this is being webcast, so if panelists around the table are speaking, please remember to be sure to introduce yourself and turn your mic on and off when you're done, as we have been doing. So thank you. So I will turn it over to Dr. Wolf for the conflict of interest.
Conflict of interest statement. Members of the NTP Technical Reports Peer Review Panel serve as independent scientists and not as a representative of any organization. Each member is to exercise judgment as to whether potential conflict of interest might exist for the topic under discussion by the panel due to his or her occupational affiliation, professional activity, or financial interest. This potential for a conflict extends to the member's spouse, minor child, partner, or organization. Members of the panel are asked to bring to the attention of the federal official any potential conflict, and it will be handled in accordance with departmental policies and regulatory requirements. Just a few minor things. If you haven't signed in at the registration desk, if you're in the audience, we ask you to please do that so that we have a record of who's in the room. I think the chair reminded everyone to please use their microphones and to introduce yourself for the webcast. As I mentioned previously, we will share the peer review report with you after the meeting. Slides will be posted to the NTP website after they're made 508 compliant for accessibility. And at the end of the day, we will accommodate you either back to the hotel or to the airport so that you can leave and go home. Thank you very much.
Thank you. Okay, we will now revisit our charge with Dr. Blystone.
Okay, similar to the charge that we had yesterday, you will be reviewing technical reports which describe the NTP's methods, results, and conclusions as levels of evidence for carcinogenic activity under the specific conditions of the study. Just to review these levels of evidence, this is the top two are positive calls, the first being clear evidence, and this is a dose-related increase in malignant neoplasms, an increase in a combination of malignant and benign neoplasms, or a marked increase of benign neoplasms when there's an indication from this or other studies that these may progress to malignancy. The next step down is some evidence of carcinogenic activity, where we have a chemical-related increase of neoplasms in which the strength of the response is less than what that is required for clear. And then we have equivocal evidence, which the response may or may not be related to the agent's exposure. And then no evidence of carcinogenic activity. And lastly, inadequate study, in which issues preclude interpretation of the study's results. Yesterday we reviewed the mouse report with the exposure to 1900 megahertz. Today, this morning, we'll begin the review of the rat report. This is exposure to the HSD Sprague-Dawley SD rat with to 900 megahertz with the similar modulations of CDMA and GSM. And the charge of the panel will be to, I did something. All right, to review and evaluate the scientific and technical elements of the study and its presentation, and determine whether the study's experimental design, conduct, and findings support the NTP's conclusions regarding the carcinogenic activity and toxicity of the tested agent. And with that, I'll take any questions.
Charge is clear to everyone. Thank you. Any questions for clarification? If not, I will turn this over to Dr. Wyde for the discussion of the NTP rat study.
All right. Thank you and good morning to everybody. We've made it to the last day, and today we'll be talking about the rat studies. There's a lot more to cover today than there was yesterday, so I have a couple more slides than I did for the mouse study yesterday. Here's an outline of my talk. First, we'll talk about, as we mentioned, and as you know, we released a partial findings report from these rat studies in May of 2016. So we'll talk a little bit about the partial findings report. I'll talk about the study designs for both the 28-day studies and the 2-year studies. I'll go through the results for the 28-day studies, both the GSM and CDMA. Then we'll talk about the results from the 2-year studies. First, we'll talk about the 14-week interim, just like we did yesterday with the mice, and then we'll talk about the results from the 2-year studies for each GSM and CDMA. And then lastly, we'll talk about the conclusions. We'll post the conclusions in their bulleted form, just like we did yesterday for the mice. So first, as I mentioned, I wanted to talk about the partial findings report. Just to give you a little bit of history about this report, everything with this report started back in December of 2015 when we received the lab report from ITRI. When we looked at this lab report, some concern was raised regarding the findings in the brain and the heart. This sparked us to do a complete review of the brains and the heart lesions. Dr. Sesta's name's up here. He didn't undertake this himself, but his name's here because he'll be discussing this in greater detail in his talk, which follows mine. Over the time after this and during this, we prepared a partial findings report, which is what was released. This report was peer-reviewed here at NTP blindly, and then at the NIH level, it was reviewed again. And then, as I mentioned, this report was released in May of 2016 and has been updated twice since then. And this report can be found online. Here's the link. And I believe that these slides will be available, so you could go to that link there. And that's the title of the report that appears online at the bioRxives website. So just to talk about the study designs, these designs are a little more complicated than the designs in the mice because these designs include in utero exposure. So first we'll talk about the design for the 28-day prechronic studies. 28-day is kind of a bit of a misnomer. We call it the 28-day study because it's the similar types of exposures as we did in the 28-day mouse study. But I'll just kind of point out down here, exposure started during gestation. So here I've divided this slide into 3 sections. We see the gestation period here from conception to littering, and we see the lactation period here from littering until weaning, and then we see here this postnatal exposure period. So in the report, we refer to this period as the perinatal exposure period, and this includes from the beginning of exposure at gestation day 6 through weaning on postnatal day 21. The 28 days, which we refer to here as the 28-day study, refers to the 28 days that the study was counted starting from weaning, where the animals were exposed individually, where they were then taken out for the 28 days. So these animals were actually 49 days of age when they were necropsied. So technically, they were exposed for 15 days in utero, and then the 21 days of lactation, and the 28 days. So this was a total of 64 days of actual exposure, with part of that being in utero. So as I mentioned yesterday, the exposures for these studies were in rats 3, 6, and 9 watts per kilogram. They were exposed to either GSM modulation or CDMA modulation, as we've discussed over the last 2 days, with the exposures being on a 10-minute on, 10-minute off cycling, as we've discussed. And again, as I mentioned, these exposures were begun in utero on gestation day 6 and terminated 28 days after weaning. We had similar exposure for the 2-year study, except that the main difference here is that the exposure duration in this part of the study, so the exposure started on gestation day 5, it continued through gestation, lactation, and then continued starting the 2-year time point, or the 14-week time point started here at postnatal day 21, and then the animals were exposed to either 14 weeks or up to 106 weeks until terminal necropsy. And again, in the report, we refer to this period as the perinatal exposure period and this period as the postnatal exposure period. So first we'll talk about the 28-day study results. And we'll talk first about the GSM studies. So the first thing that we'll talk about is the perinatal effects that were observed in these studies. And something to keep in mind is when we're looking at the perinatal exposure period, at first during gestation, we're looking at just the dams because there's no pups yet. And then during lactation, we have data for both the dams as well as the pups. And then beyond that, for the 28-day exposure period, we're just looking at the pups themselves. So first, we see that for the dams, that there was a negative trend for body weights in the dams at gestation day 21. This was at the end of gestation. We also saw that there was a decrease, about 9% in body weight gains over the gestation period, covering from GD6 to 21. And this occurred in dams at 9 watts per kilogram. There was no exposure-related effects on maternal survival during this period, or the littering rates when the animals were littering. There was no impact on total and live litter size throughout the lactation period either. There was, however, in the pups throughout the lactation period, or actually early on in the lactation period, an increased number or a higher number of dead pups per litter, and that translated to a decreased survival ratio, and this occurred at the 9 watts per kilogram exposures. And again, we saw this effect before culling. This occurred in the first few days between postnatal day 1 and postnatal day 4. In the dams during the lactation period, we actually saw that there was decreased body weights and decreased body weight gains at 9 watts per kilogram. This has occurred, as I mentioned, throughout the lactation period. There was a negative SAR-dependent trend that was generally observed throughout this period, and a significant decrease was observed in all exposure groups at weaning at PND 21 compared to controls. And again, this was in the dams. In the pups, when we look at the pups during this lactation period, we see that there was an 8 to 18% decrease in the adjusted pup weights. When you look at males and females combined, this occurred throughout the lactation period, and this occurred only at the 9 watts per kilogram exposure. We did see some decreases, much less robust response, lower response here at the 6 watts per kilogram males as well, just looking at the males alone. So you could see that most of these effects that occurred for the perinatal exposures occurred at the 9 watts per kilogram exposure. This wasn't necessarily surprising considering some of the data that we had seen in the thermal pilot study suggesting that there may be increased rises in temperature that would be potentially excessive. So as I mentioned, now we're moving on to this postnatal exposure period. So this is the period from postnatal day 21 through postnatal day 49. So this is the 28-day period. There was no exposure-related effect on survival or in clinical signs of toxicity during this part of the study. There was, however, lower mean body weights at both 6 and 9 watts per kilogram in males and at 9 watts per kilogram in females. And this occurred throughout the 28-day post-weaning period. It seems as though they started off small and continued to stay small. However, in the females, as the 28 days progressed, we actually saw that these decreases mitigated over that period of time, and that by the end of necropsy, at the end of the 28 days, that the body weights between the females in this group and the controls were actually similar. There was also an SAR-dependent decrease in body weights of about 7 to 18% of the males at necropsy. And an interesting finding in this study was that there was a higher incidence of minimal chronic progressive nephropathy in all groups of females exposed to RFR when you compare it to the controls. We also in this study looked at body temperatures, just as we did with the mice. The results for this demonstrated that there were increase in body temperatures in the dams at both 6 and 9 watts per kilogram during gestation and lactation. The sporadic increases that were observed at 6 watts per kilogram were below this 1 degree C set point that we've discussed yesterday and I believe the day before. And the increases at the 9 watt per kilogram exposures were either equal to or exceeded this 1 degree C mark. And again, this wasn't surprising considering the results that we had at 8 watts per kilogram and 10 watts per kilogram from the thermal pilot studies. So this concludes the GSM portions. We'll move into the CDMA modulation. We actually saw a very similar response for CDMA as we saw with GSM exposures. Again, first we'll cover this perinatal exposure period. So just like we saw for the GSM exposed animals, we saw a negative trend in body weights at the end of gestation, gestation day 21. Again, we saw decreased body weight gains over the gestation period from GD6 to 21, just as we did with the GSM studies, and this occurred in the dams at 9 watts per kilogram. Again, there were no exposure-related effects on the maternal survival during this period of gestation or lactation. The littering rates were not affected by exposure, and neither were the total and live litter size throughout the lactation period. We did again see a higher number of dead pups in the 9 watts per kilogram group. This time, with this exposure, we saw this occurring after culling on PND4. So this occurred in the period PND5 through PND21. So this effect was similar, but it occurred at a little bit later time point than what was observed for GSM. But in this study, we didn't see an effect or a significant effect on the survival ratio throughout lactation. Similarly, when you look at the dams during the lactation period, we saw that there were decreased body weights and body weight gains at the 9 watt per kilogram exposures. This was also reflected as a negative trend, negative SAR dependent trend that was generally observed throughout the whole lactation period. When we look at the pups, we see that there was about a 14 to 23% decrease in the adjusted pup weights when you look at the combined weights of the males and females from the litters. This occurred throughout the lactation period and occurred at the 9 watt per kilogram exposures. And again, just like we saw with the GSM exposures, we see that at 6 watts per kilogram, there was a lesser decrease, but there was a decrease that was observed at this exposure as well. So again, for these perinatal effects, you can see that most of these effects occur at the 9 watt per kilogram exposure levels. Just like with GSM, we saw no exposure-related effects on survival or clinical signs of toxicity in the CDMA studies. But we did again see lower mean body weights that were observed at 9 watts per kilogram in both the males and females compared to controls. In the males, this decrease was observed throughout the exposure period, throughout this postnatal exposure period of the 28 days. And at necropsy. But again, just like we saw with the GSM study, the females, while they started off decreased, this decrease mitigated over time, and that by the end of the necropsy, at the end of the 28 days, there was no differences between these exposures and controls. And again, we saw the same thing, this finding in female rats, that there was a higher incidence of minimal chronic progressive nephropathy in all the groups of females compared to controls. There was a positive trend in this case and a statistically significant increase at the 6 watts per kilogram exposure level. When we look at body temperatures, we saw basically the similar findings as we saw for the GSM exposures. We saw increase in body temperatures at 9 watts per kilogram during the gestation and lactation period in the dams. These increases at the 9 watts per kilogram exceeded this 1 degree C limit, and again, this is consistent with what we saw in the thermal pilot studies. We did see some sporadic changes in temperature at 6 watts per kilogram, and again, these increases were below the 1 degree C set point. And let's see. So with the 28-day studies completed, we looked forward to the 2-year studies and needed to select exposures for the 2-year studies. So we took all the information that we had from both the thermal pilot studies as well as the 28-day studies, and what I've done is I've kind of combined all of this data here to look from a dose perspective or an exposure perspective what we observed in these studies combined. So at 9 watts per kilogram, just to refresh your memory, we saw reduced maternal and pup weights. We also saw an increased number of dead pups and decreased survival ratio in GSM. We also saw an increase in dead pups for the CDMA exposures. We saw an increased body temperature in pregnant rats during gestation and in dams during lactation that exceeded this 1 degree C. And therefore, we believe that 9 watts per kilogram was obviously too high to expose for the 2-year studies. Looking at the effects at 8 watts per kilogram, this was what we had exposed during the thermal pilot studies. We did see an increase that exceeded the 1 degree C in the young GSM males and aged male rats, regardless of sex. So again, we believe that this was excessive exposures for selecting for the 2-year studies. When we looked at 6 watts per kilogram, we observed some minor effects. We saw decreased pup weights during lactation that were lower throughout the 28-day studies, and we did see increases in temperature, but these were below the 1 degree C set point. And so we believe that this was an adequate level to challenge the animals. But we also, there was some issue brought up yesterday as far as the spacing of the doses. or the exposures. And so this was how we determined the high end of exposure. But as we look at spacing for doses down, we selected half doses. So we selected 3 watts per kilogram and 1.5 watts per kilogram. With this spacing, this 1.5 put us close to the 1.6 exposure limit that the FCC recommends, and close to the 2.0 watts per kilogram limit that are utilized in Europe. With our toxicology study, we wanted to make sure that we actually saw some response. We want to be a good toxicology study is selects doses that are within the dose response range where we can actually see something occurring. So if we go too low and we only see something at the high dose, it might be difficult for us to see this. So if we spread the doses out too low, if we did these by thirds, this would be 6, 2, and 0.67. We believe that those 2 lower doses, we might not be able to see anything, especially because when we looked at 4 watts per kilogram in the thermal pilot study, we didn't seem to see much. And when we looked at 3 watts per kilogram in the 28-day study, we didn't really see much. So this is why we selected these particular doses and this range of exposures. So we'll talk about the 2-year studies. We'll talk about GSM modulation first. We'll go through, first we'll talk about the perinatal effects that were observed, and then we'll talk about the 14-week exposures, and then go right into the 2-year summaries. So we saw, for the perinatal portion of the GSM exposures, we saw that a similar effect to what we saw in the 28-day studies. We saw that there was a negative trend for body weights and dams that occurred towards the end of the gestation period between gestation days 18 and 21. We saw about a 7% decrease in body weight gains over the gestation period of exposure from GD6 to GD21 in dams at 6 watts per kilogram when compared to controls. We also saw that there were no effects related to maternal survival, the littering rates, total and live litter size throughout lactation, or the pup mortality or survival ratio throughout the lactation period. And we saw decreased body weights and body weight gains at the 3 and 6 watt per kilogram dams throughout the lactation period. And there was a negative trend for this decrease in body weight that was generally observed throughout this entire lactation period. When we look at the pups, again, just like we did for the 28-day studies, if you look at the adjusted pup weights for the combined males and females from the litters, we see that there was a 6 to 9% decrease throughout the lactation period at the 6 watt per kilogram exposure compared to controls. And we see that there was a more minor effect that was observed at the 3 watt per kilogram exposure that were slightly lower than what we observed at the 6 watt per kilogram exposures. So with the 14-week evaluations, we actually did see some histopathological findings. We saw that there was some findings in the heart as well as the mandibular lymph node. So if we look at the heart, again, there were 10 animals per group in the interim evaluation, so there were 10 animals that were observed. We see that there is a higher incidence of the right ventricular cardiomyopathy at the 3 and 6 watt per kilogram exposures. These are not statistically significant, but they are elevated compared to controls. When we look at cardiomyopathy across the whole heart, which includes the right ventricle as well as the left ventricle and the rest of the heart, we see there's a statistically significant increase here at the 3 watt per kilogram exposure, and all of the exposure concentrations are above what we observed in the controls. And this seems to be primarily driven by what's occurring in the right ventricle. And again, this was only observed in the hearts of male rats. Lymph node, we actually saw lymphocyte hyperplasia. This was an increased incidence that was observed at the 6 watt per kilogram exposure. And these were males. In females, we didn't see any exposure-related effects on histopathology at this 14-week time point. Now, as I mentioned yesterday for the mice, at this 14-week time point, one of the other things that we did evaluate was gene tox. As Christine Witt had mentioned yesterday, we looked at both the micronucleus assay as well as the common assay. And for GSM, both of these studies were negative. We see a negative micronucleus assay result as well as a negative result in the common assay. Again, for the common assay, we looked at 3 different tissues, the brain, liver, and blood, and we looked at 3 different regions within the brain. Again, the frontal cortex, the hippocampus, and the cerebellum. When we get to the end of the 2-year study, what we found is that there, and this has been mentioned, I think, over the last day or two, that there was a greater survival in the exposed males, in all of the exposed male groups compared to the controls. As you can see, this is the control survival here, and you can see that all of the exposures were exposure groups had survivals that were exceeded the exposure groups in the males controls. This lower survival in the control group was attributed to high severity of chronic progressive nephropathy. I'll talk a little bit more about this later when we talk about the lesions themselves, and we'll look at the numbers. Primary finding in these studies was an increased incidence in malignant schwannomas of the heart in male rats. And Dr. Sesta will talk about this at great length in his talk. I don't want to steal much of his thunder, but this is a picture of the lesion that occurs right here and throughout here. Again, Dr. Sesta will talk about this lesion in his talk, but I want to talk about the actual incidences of these lesions. This is, again, the only positive finding that we were able to glean from the study. We see that the incidence here in controls was 0, so there were no incidences of malignant schwannomas in the control animals. We see that there were incidences that occurred at the 1.5 watts and 3 watt per kilogram, but there was actually a much higher incidence in the 6 watt per kilogram exposure. And if you look at the historical controls here, the historical control rate, we see 2 out of 240 animals. Again, this includes the concurrent controls. There's a rate of 1%. With a range of 0 to 2%. Here in this case, this 5 is 5.5%, or rounded it would be 6%. So this value here exceeds the 2%. This value at 1.5 is right at the upper end of the historical control range. When we look at the supporting evidence from the Schwann cell hyperplasia, which is a preneoplastic lesion that's believed to maybe have the potential to progress onto a malignant schwannoma, we see that there was incidences of Schwann cell hyperplasia at the 1.5 and 6 watt per kilogram exposures. On the bottom of this slide, we've included the female incidences, not because these were significant, but just so we can compare those. You can look and compare those to what was observed in the males. The other thing that was observed here in the 2-year study that, as I mentioned, was also observed in the 14-day study is that we saw an increase in this right ventricular cardiomyopathy. And again, this is something that Dr. Sesta will talk about in further detail in his talk. But we did see that this was a statistically significant increase that occurred at the 3 and the 6 watt per kilogram exposures. This occurred both in males as well as females. Obviously, this occurred to a much lesser extent, but the background rate of this lesion seems to be lower in females as well. So this demonstrates then that the heart is likely is a target organ of RFR exposure. So now, just like we did with the mice, we had a collection of lesions that were considered to be equivocal findings. I've gathered these together in this table here, and we'll go through these each one by one as we did yesterday for the mice. We did see lesions in the prostate, 2 different types of lesions in the brain, lesion in the pituitary gland, the adrenal medulla, and the pancreatic islet cells. In the males, and we saw that there were no lesions that were considered equivocal in the females exposed to GSM. So first we'll talk about the prostate gland. Here, if you look at the incidences, the combined incidences of adenoma and carcinoma, we see that there was a higher incidence at the 3 watt per kilogram exposure group compared to controls. We see that this incidence is relatively flat for the 1.5 and 6 watt per kilogram exposure. So we see this at 3, but not at 6 watts per kilogram. we look at the historical control rate for this lesion, we see that there were 2 animals out of 240. The range is 0 to 2%. This 2% is here in this study because this is 2% here. This would be about 7.7%. So we see that the value here at the 3 watt per kilogram exposure exceeds historical controls. The value here at 6 watts per kilogram at 3.3% does also slightly exceed historical controls, but just barely. So based on these exposures, the lack of a dose response, the lack of a statistical significance, however, we do see this increase at one of the exposures, but not at the highest exposure. This decreased our confidence and led us to the conclusion that this was an equivocal finding. Next, we'll move on to the brain. In males, we're looking at the malignant gliomas. Again, just like we saw with the cardiac schwannomas, we see that the incidence here in controls was 0. We see that there was incidences that were observed in all of the exposure groups, slight increases that were not statistically significant. There was no significant positive trend test, but these exposures all also fell within the range of the historical controls. Based on the fact that we saw this in all 3 of these exposure groups, and as well that we saw the supporting evidence from the hyperplastic lesion, the glial cell hyperplasias, which are believed to have the potential to develop into malignant gliomas. We also saw incidences of this lesion in all of the exposure groups. And again, we didn't see this lesion at all in the controls. Based on these findings, the fact that these were increased above controls but not statistically significant and were relatively close to the upper limit of the historical control range, we had decreased confidence that these were actually related to treatment. However, we couldn't write these off completely, so we considered that these were equivocal findings that may have been related to exposure to RF. We'll stay in the brain, but we're going to move to a different cell type. Looking at the granule cell tumors, we saw that there was, if we look at the combined incidence here of granular cell tumors, either benign or malignant, we see that we had an incidence of 1 in the control compared to a higher incidence in each of the exposure groups. We see a relatively flat response across the SARs. But we do see, again, if we look at the granular cell hyperplasia, we do see an incidence of 1 in the control and 1 in the 3 watt per kilogram exposures. We compare this to historical controls. We saw that there was a historical control average of about 1.7% and a range of 0 to 4%. All of these, this would be 3.3, 4.4, and 3.3%. These are towards the high end of the historical control range, but do fall pretty much within, with the exception of this 4.4 being very close to the 4%. So these did not exceed necessarily the historical control range. They were not statistically significant, and there was no SAR-dependent increase. However, we did see this higher incidence compared to controls, so we again considered this to be an equivocal finding. We'll move next to the pituitary gland. Here we see that the incidence of adenoma is relatively high in the control animals. We'd see incidences that were higher than controls in all 3 of the exposure groups, like we've seen for some of these other lesions. The incidences here, when you compare them to the historical control, the range is 10 to 28%. These do exceed this because you have to convert these into percentages. So these all just do barely exceed the historical control range. But we don't see any trend, and we don't see any pairwise significance when we look at the statistics. So again, this decreased our confidence that this lesion was then a direct result of the exposure to RFR. So we considered this to be an equivocal finding as well. Moving to the adrenal medulla, we saw that there was an increase in this benign pheochromocytoma, but we we're looking for the call at the combination of these lesions, the benign, malignant, or complex pheochromocytoma. We do, in this case, see a statistically significant increase at the low and mid exposures compared to controls. At the high dose, we see that there's no difference when you look pairwise compared to the controls, and we don't see a statistically significant trend test here. However, we do see this increase at both of these exposures, and when we compare this to the historical control rate, we see a range of 13 to 28%. These exposures do exceed the historical control range that were observed, but because we didn't see necessarily an SAR-dependent increase, and we did see this decrease at the upper exposure, we considered this to be an equivocal finding. For females, we didn't see any change in the number of tumors. However, we did see adrenomedulla hyperplasia that was increased at the upper exposure limit, or at the upper exposure at 6 watts per kilogram. It appears to be that there may be some increase in severity as well, but it seems like the severity is pretty similar between the control and the exposed group, where we see an increase in the incidence. We'll move next to the pancreatic islets. And this will be the last of our neoplasms for the GSM males. When we look at the combined incidence of adenomas and carcinomas, we see that there is an incidence of 13 in the control. We see that the incidence in each of the exposure groups actually exceeds what was observed in the control. However, we saw that there was only statistical significance at the lowest exposure, where we saw 27 of the animals with this lesion. We did see higher, as I mentioned, incidences here and here, but again, most of our effect was occurring at the 1.5 watt per kilogram exposures. If we look at the historical control rate, we see that the average is 10% with a range from 4 to 16%. The incidence here exceeds the historical control range by quite a bit, but as we move into these upper exposures, these do exceed the historical control range, but only marginally. So in this case, we do see that there is an increase here compared to controls, but it seems as though there's a decreasing effect as you increase SAR. So there's no trend test, and our statistical significance is only at the lowest exposure. So this decreased our confidence that these lesions were related directly to the RFR exposure. So again, we consider these findings to be equivocal. There was one non-neoplastic, actually two non-neoplastic lesions. First, we'll talk about the thyroid C-cell hyperplasia. These were lesions that were not associated with any neoplasms. Obviously, I showed some non-neoplastic lesions when they were identified with the neoplasms. Here, in this case, we see in females that there was a statistically significant increase in all the exposure groups compared to controls for thyroid C-cell hyperplasia. And again, we don't necessarily see a very robust dose response, but we do see that this is elevated in all of the exposure, all the exposed animals compared to the control group. As I mentioned previously, the decreased survival in the control animals was determined to be related to a high level or a high severity of chronic progressive nephropathy in the kidney. Here we'll take a look at the actual numbers. It's not necessarily that we see an increase or a change in the incidence itself, but we do see a change in the severity with a much higher severity here, 3.7. I believe Dr. Melnick mentioned this in his talk yesterday, that this is quite high compared to what we've historically seen. And we see that there is a decrease as you increase SAR, that there's a decreasing severity of the CPN that's observed in these animals. And we report in the report that there is a number of lesions that are related to this chronic progressive nephropathy that are secondary to this lesion. And there's just a list here. I didn't list the actual lesions themselves. I just listed the tissues in which these lesions were observed. But a full list of these lesions, you can look on table 29 in the report. This is on page 113 of the tech report that you have in front of you. As you can see, again, there is a significant decrease in the severity, and we actually see a significant decrease in a lot of these lesions as you look at the higher SARs. So that's all we had for the GSM. We'll move to the CDMA modulation. And first, again, we'll talk about the perinatal exposure. Then we'll move into the 14-day, and then we'll talk about the 2-year. So again, we saw very similar effects in the perinatal portion of this study for the CDMA as we did for GSM. We saw no exposure-related effects on maternal body weights or survival or littering rates or the total and live litter size on the PND1. We saw a decrease in live pups per litter at the 6 watt per kilogram exposure after PND4 compared to controls, and this corresponds to a decrease in the survival ratio at this exposure, 6 watts per kilogram, and this occurred after culling in the period between postnatal day 4 and postnatal day 21. We look at the dams during lactation. We see that there was decreased body weights and body weight gains at the 3 and 6 watt per kilogram exposures compared to control. This was a negative trend that seemed to be observed generally throughout the entire lactation period. When we look at the pups, this is after gestation and into the lactation period, we look at the pups. There is a 9 to 14% decrease in the adjusted pup weights when we combine the males and females from those litters. And this was observed at the 6 watts per kilogram exposure. And again, we did see more minor decrease, at the 3 watts per kilogram, but not throughout lactation. This only occurred on PND4, and this was a very minor change of 5% in body weights. So 14-week exposure, we saw basically something very similar to what we saw in the GSM exposures. We saw that there was a higher incidence of right ventricular cardiomyopathy in these animals. Again, this was not a statistically significant increase, but there was a higher incidence of these compared to controls. And again, when we look at the whole heart, it seems like what may be occurring here is being driven by what we observe in the right ventricle. And just like we saw for GSM, there were no exposure-related effects at this time point for female rats. Moving into the gene tox, for the micronucleus assay, just like we saw for the GSM studies, there was no increase in the frequency of micronucleated cells. This is, again, I've got listed for both GSM and CDMA. This is, again, consistent with what we saw yesterday for the mice as well. When we look at the COMET assay, we actually did see a positive finding here and one finding that was considered equivocal. The positive finding was in the male hippocampus. When we look at the frontal cortex, this finding was equivocal. We'll actually look at this data in these next slides. Otherwise, everything was negative in male rats for the cerebellum, liver, and blood, and all of the tests were negative for the female rats in the COMET assay. So here is the dot plot. This is very similar to what we saw yesterday for the mice. This shows the individual animal data and the treatment group means for the COMET assay in male rats. This is for the hippocampus again. As we see, there was a positive trend and also the pairwise significance here at this highest exposure. But as Christine Witt mentioned yesterday, we did see a lot of inter-individual variability between the animals. We almost saw what seemed like maybe responders and non-responders in these groups when you look at all of the data. As you can see here, there's one animal that is very responsive compared to some that are perhaps pretty close to the controls. This was, again, considered to be a positive result based on the findings that there was an increased trend and a significant pairwise at the highest exposure. When we look at the frontal cortex, there was a positive trend here. As you can see, this looks like a positive trend. However, due to the inter-individual variability, there was this group, which seems like it may be higher than the controls, was not considered statistically significant. And again, here you almost see like there's a group of responders and non-responders that are down along this control level. So I think this inter-individual variability prevented us from really being able to discern between what may be happening. If we had more animals here, we might actually be able to see that this was significant. But in this case, this conclusion that we came to with this finding was that these were equivocal results. So as we move to the 2-year studies, at the conclusion of the 2-year studies, just like we saw for GSM exposures, there was an increased survival or a higher survival in the all of the exposed animals compared to the treated animals. We see this is the same control, obviously, as what was observed in the GSM, since this was a common control. So here again, we see this decrease. I think this was maybe pointed out yesterday or on the first day, that there was this decrease here that was actually lower than these controls. But as we get to the end of the study, the survival was actually higher in all of the exposed animals for males than in the controls. Again, because these are the same controls, these are common controls, the low survival in this control group was attributed to the high severity of chronic progressive nephropathy. In this study, we also saw that there was greater survival in one of the groups of females. This was the 6 watt per kilogram female group. There was a higher survival in this group compared to the control females. Again, with the GSM study, we saw that the heart was the only positive finding. Again, here's an image of that lesion, just do a little bit more of Dr. Sesta's thunder. Again, he will be talking more about the lesion itself, but I want to talk about the incidences of this lesion. We see similar results here of what we saw with the GSM study. We saw that there was a significant trend across the doses. We actually, in this case, see that this highest exposure was statistically significant when compared to controls by pairwise comparison. And we see that this 3 watts per kilogram again exceeds the historical control incidence of 2 watts per kilogram, because there was a dose response here. There was statistical significance in the trend and the highest exposure. This was considered to be a positive finding and considered some evidence for carcinogenicity. Again, on this slide, we've included the females mostly just for comparisons to the males, but we didn't see any treatment-related effect in the females. Again, similar to what we saw in the GSM studies, as well as in the 14-week studies for both GSM and CDMA, we see that there is an increase incidence of this right ventricular cardiomyopathy at the highest exposure. And in this case, we do potentially see that there is an increase in the severity as well. This was statistically significant at this highest exposure. And again, we did see this increase or higher incidences in the female rats and the exposed rats compared to controls, but these values were not statistically different from the controls. And again, we just reported these to compare to the males. So again, that was the information that demonstrated that the heart is a target organ for RFR. Again, we have several lesions that were considered to be equivocal findings. This is a table of those lesions. We'll go through these one by one again. We'll look at the brain, pituitary gland, and the liver in the CDMA males, and the brains, again, in the females, and the adrenal medulla in the females. So first we'll look at the males. Look first at the brain lesions. Actually, for this lesion, we'll look at both the males and females. First, we'll address the males. We see that there was, obviously, because this is a common control, there was, like I mentioned in the GSM study, there was no incidence of this lesion in the control group. There was also none in either the 1.5 or 3 watt per kilogram exposure groups. However, we did see an incidence of 3 at the 6 watt per kilogram exposure group. This is also the highest incidence that was observed in the GSM exposures. However, in those studies, we saw that there was incidences here at those low and mid exposures as well. Again, when we look compared to the historical control, we see that there was a 1.3% incidence with a range of 0 to 4%. This value here did not exceed that 4%. However, we did see that this was higher than controls, and this was relatively low, very low control value. And so this, again, since there was no statistically significant or no SIR dependent increase, this was considered to be an equivocal finding. Here we see very similar results here with the females, except that the incidence that we see is actually at the lowest exposure, not any incidences at the mid and high exposure groups. When we compare this to the incidence for the historical controls for females, this is a little bit lower at 0 to 2%. This 3% does exceed the historical control rate, but again, this is in the lowest exposure group and not at the mid and high exposures. And therefore, we consider this to be an equivocal finding since we didn't see it in all of the exposure groups and we didn't see an SAR-dependent increase. We'll move on next to the pituitary gland. So we look at the incidence of adenoma. We see that, again, as I mentioned, this is 17 animals in the control group. We did see higher incidence in the 1.5 watt per kilogram and a statistically significant increase at 3 watts per kilogram, but the incidence at the highest exposure was actually below what we saw for the controls, so this was similar to the controls. When we look at the historical controls, we see that the range for this lesion is 10 to 28%. This value here is close to the upper end, but this value at the 3 watts per kilogram exceeds the historical control, is statistically significant. However, we don't see an increase in trend, and we don't see an increase statistically significant or an increase here at the 6 watts per kilogram. So this lack of an SAR-dependent increase, but however, we did see the statistically significant increase. Again, this kind of decreased our confidence that these lesions were then related to the RF exposure. So we considered this, again, to be equivocal evidence of carcinogenicity. We'll move on to the adrenal medulla. For the adrenal medulla, again, we're looking at this combined incidence of the benign, malignant, or complex pheochromocytoma. The incidence in control, we saw one of these lesions in the control group. There was a statistically significant increase at the 1.5 watt per kilogram exposures. We did see higher incidences also at the 3 and 6 watt per kilogram exposures, but these incidences were not statistically significant by pairwise comparison, and there was not a statistically significant trend. When we look at this incidence compared to the historical controls, we see that there's a range of 0 to 10%. This lesion here is 9.9%, which is right at the upper edge of the historical control. However, since this is statistically significant and quite a bit higher than the concurrent control, but not in this dose-dependent fashion, we only see this at the lowest exposure. This again reduced our confidence that this lesion was related to the RFR exposure, and we considered this to be an equivocal finding. So the last neoplasm that we are reporting in males is the combined incidences of hepatocellular adenoma and carcinoma. We see that the historical control incidence for this lesion is very low. We see in the concurrent control that there was none of these lesions, either the adenoma or carcinoma, observed in the concurrent study and the concurrent controls. However, we did see incidences, even one incidence at the highest exposure and incidences at both 1.5 and 3 watt per kilogram exposure compared to the none that we saw in controls. However, there was no statistically significant trend here. The increase here, or the incidence, was higher than controls, but not statistically significant than controls at this middle exposure. Again, when we look at the historical controls, I said they're quite low. The range is 0 to 2%. This value here exceeds the historical control value. When we look at the lower exposure, this is right at the high end of our historical control. But again, we don't see an increase here at the 6 watts per kilogram. So as far as the dose response is concerned, we don't see that. And we only see this increase at the middle exposure. So again, this decreased our confidence that these lesions were related to the exposure of RFR. There was one non-neoplastic lesion that wasn't mentioned in these slides. That's the prostate gland. We saw epithelial hyperplasia that was increased. We saw higher incidences across all of the exposures, but there was a statistically significant increase at the highest exposure of 6 watts per kilogram. I said there was one lesion. The other lesion, there actually was 2 lesions. The other lesion was what we discussed for the GSM exposures was that there was an increase in chronic progressive nephropathy. These are the numbers for the CDMA exposures, and we see a similar thing, that there really is no change at all in the incidence. It seems like almost all of the animals, because this is an age-related lesion, have an incidence of this chronic progressive nephropathy, but we see, as we increase SAR, that there is a significant, or a marked, I should say, decrease in the severity of this lesion. And again, when we look at those secondary lesions, which I've listed the organs here that these were observed in, we see that there is an SAR-dependent decrease in these lesions when you look at each of these lesions across the board. And again, for this, there's a full list of these lesions if you want to look in the tech report. This is in table 55 on page 148 if you want to refer to the individual lesions. So that was all we saw for both the GSM and CDMA studies in the rats. So we'll move right into the conclusions. We'll look at this just like we did for the mice. We'll look at the males for each of this modulation, the females for this modulation, and then we'll look at males and females for the CDMA modulation. So based under the conditions of this study, it was determined that there was some evidence of carcinogenicity or carcinogenic activity in male HSD rats exposed to GSM-modulated RFR at 900 megahertz. This was based on the incidences of malignant schwannomas in the heart. And there were several other lesions that these are considered equivocal evidence. These lesions may have been related to exposure to cell phone RFR, and these lesions include the incidence of adenoma or carcinoma, these combined incidences in the prostate gland, malignant glioma, and benign or malignant granular cell lesions in the brain. Also the adenoma of the pars distalis in the pituitary gland, the incidences of pheochromocytoma. This is the combined incidences again, benign, malignant, and complex, of the adrenal medulla, and based on the incidences of pancreatic islet cell adenoma or carcinoma combined. So again, this is some evidence, and these lesions are considered equivocal evidence and may have been related to treatment. As for non-neoplastic lesions, we did see non-neoplastic lesions in the heart. As I mentioned, this was the Schwann cell hyperplasia, in the brain, glial cell hyperplasia, and in the prostate gland as well. For the females, for the GSM modulation, there was no evidence of carcinogenic activity. However, we did see non-neoplastic lesions that occurred in the heart, the thyroid, and the adrenal gland. For the CDMA modulation, again, for males, there was some evidence of carcinogenic activity in HSD Sprague Dawley rats exposed to CDMA modulated cell phone RFR at 900 megahertz. This was based on the incidences of malignant schwannoma in the heart. And again, we have a number of lesions that we considered to be equivocal findings. These are termed to be, may have been related to cell phone RF exposure. These lesions include a malignant glioma of the brain, the adenoma of the pars distalis of the pituitary gland, and the combined incidences of adenoma and carcinoma of the liver. We also did observe non-neoplastic lesions. These occurred in the heart, the brain, and the prostate gland in the male rats. For the females, for the CDMA modulation, we conclude that there was equivocal evidence of carcinogenic activity based on the incidence of malignant glioma in the brain and pheochromocytoma in the adrenal medulla. And the non-neoplastic lesions that were observed in the CDMA exposed females, there was lesions in the brain. And that's it.
Thank you, Dr. Wide. Questions to Dr. Wide from the panel? Dr. Jones.
Lydia Andrews Jones. Could you tell me where in the brain these lesions were? What subanatomic area?
I'm not sure that they were limited to one particular region. In fact, Dr. Sesta had gone through and looked at those, and he could.
Mark Sesta. Yeah, I went and looked to see if there was any particular anatomic location, but there wasn't. They were scattered all over the brain.
Other questions from the committee to Dr. White? Yes, Sue?
I have a couple of questions that are on different topics. So my first question is how you regarded with the CDMA modulation, the impact on the pups, the survival in particular, but also the decreased body weight, and whether that would meet the bar for exceeding an MTD in an NTP bioassay. And I think, related to that, there can be discussions about the impact of, if we're in a range that might be exceeding an MTD, the impact that would have on consequences later in life, including the body weight changes that were not insignificant biologically.
I think the level of the decreases, when we look at the 28-day study, when you look at the 9 watts per kilogram, were quite significant. But when you look at the 2-year study for the 6 watts per kilogram, I don't know the number off the top of my head. I think it was about 6% decrease, and we didn't consider that these would be exceeding an MTD.
So for the CDMA, it was 9 to 14% decreased pup weight. That's what I jotted down.
I just want to add a little bit that we consider these to be sort of growth delays and not exceeding MTDs. The pups caught up, and there wasn't a continued delay or decreases as they were weaned. And so we consider this to be a transitory effect.
So can you say a little bit more then about the decreased live pups per litter that was specific for the postnatal day 4 reading, specifically in the high dose group?
Yes, and so for the high dose, we do believe the decrease in survival was in effect. It was, I believe it was about 6%, and the number of pups that were, I think it was 22 out of 500 or so. So I think we had a really high-powered study to detect this effect, and we do believe it's real, but I don't think it was significant enough to alter the effects or exceed the MTD.
And just to reiterate Dr. Blastow's comment, if you look at the growth curves over the course of the 2-year study, you can see that those animals are very similar to the weights that were observed for controls.
That's fine, yes, go ahead, Dr. Phil.
Okay, yeah, my next question's on a different topic. And I don't know if you can look up the information as I'm talking to help me understand it, but in the GSM females for which there were no target organs identified for cancer, looking at the heart, there are 3 different tumor types, each of which had a single animal, and I don't know if these were the same animal or different animals. There was one in the mid-dose, one schwannoma, malignant schwannoma, one paraganglioma, and one malignant schwannoma in the myocardium as opposed to the endocardium. And would those not, if those are separate animals, would they not be combined to give an incidence, or at least the 2 malignant schwannomas?
Yeah, I'm going to defer to Dr. Sesta as far as the combining of those lesions. That's more of a pathological question.
For Mark Sesta, for our analysis, we did combine the myocardial and endocardial lesions. We don't combine non-neoplastic lesions and neoplastic lesions, so we didn't combine the hyperplasias with the schwannomas, but we did combine endocardial and myocardial schwannomas and endocardial and myocardial hyperplasias.
So then can you confirm in the I always have to check which modality I'm looking at. So in the GSM females, that there was an incidence of 3 out of 90 in the mid-dose for related heart tumors?
Yeah, I believe
and none in any of the other groups, including controls, low and high dose? Is that
Yeah, I
correct?
believe that's true. That's correct, yeah.
Other questions for Dr. White? Yes, Dr. Hoffman.
Wolfgang Kaufmann. And just have a question to the litter size. The litter size may have also impact on growth rate and so on. And what was the culling? Was culling of to 8 animals per litter?
Yes.
And how were these pups distributed to the dose groups? From what litter?
Well, all of the pups were in the chamber, so we took three pups from each litter to feed into the 2-year study, but they were already exposed before birth, so those litters came from that one chamber to feed forward to the 2-year study.
Just, I think to add to that, I think it was a randomized selection of the pups. I think that if that's the point you're looking for.
And the culling was down to 8 pups.
And the culling was to equalize the lactational pressure throughout.
Thank you.
I have one question.
Dr. Jones?
Lydia Andrews-Jones, did you look at lactation in the dams as a possible source of the decreased pup weights?
No, we didn't do any specific testing or evaluation to look at that.
Yeah, Dave Malarkey. I just had a follow-up on the paraganglioma. That would not be combined with the schwannomas because it's a different cell origin.
Okay, thank you.
Yeah.
Dr. Klein?
Yeah, that was a great presentation, and I really liked the graphical study design. I'd love to see that in the final report. Just a couple of points of clarification. I presume the ears were not trimmed in this study as well?
No, the ears, I don't believe the ears are
Okay.
protocol tissue, so.
Okay, and I'm trying to track in the data the potential downstream effects of the pituitary adenomas, or that the HPA and HPG axis. Was there any gynecomastia in male animals with pituitary tumors?
No.
Okay, and I'm going to ask about adrenal weights. I know that might be a bit much to drag out on the spur of the moment, but what I'm wrestling with is whether these pituitary tumors were derived from lactotrophes, as they usually are, or whether they were corticotroph tumors. Do you have any information that might shed light on that?
No, I don't. We didn't look into that.
Okay, and one more question: the attribution of most of the lesions that are attributed or associated with the chronic progressive nephropathy makes sense to me, but there's one I have a bit of trouble with, which is attributing lymphoid organ atrophy to chronic progressive nephropathy. Is there a pathway or a mechanistic thought, rationale for that association, or is it just an observed association?
Do you want to? I'll let Dr. Sesta answer that.
Dr. Sesta.
Mark Sesta. I was actually going to touch on that in my presentation, but I can go ahead and answer now. Chronic progressive nephropathy can exacerbate polyarteritis nodosa, which is a vascular lesion, a spontaneous vascular lesion. So, and that can result in decreased blood flow. So we connected it by, explained it by the exacerbated polyarteritis nodosa with a decreased blood flow might result in atrophy of various lesions, or various organs, sorry.
Thank you. Dr. Lin?
Just for clarification, with regard to the body weight issue, as I recall, neither food consumption or water consumption was monitored during any period of that time. Is that correct?
That's correct.
Other questions for Dr. White? Dr. Filter.
I have one other question that actually has to do with a tumor seen in a 14-week interim evaluation, and if there's any experience, I'm not familiar with it myself, to see a tumor so early at 14 weeks with an adenocarcinoma of the mammary gland in female rats at 14 weeks. Is that a highly unusual finding, or are they seen sometimes that early?
You know, yeah, that's an early onset tumor, right? We were surprised by that, but mammary tumors can occur earlier, like fibroadenomas. But
Right, but this is not a fibroadenoma, right? It's an
Carcinoma.
adenocarcinoma.
Oh. Yeah.
So I haven't evaluated 14-week studies enough to know how unusual that is. So it would be helpful to understand that better.
Hang on.
Yeah, so I just had a question around, so you obviously were trying to assess reproductive cyclicity with the vaginal swabs. In your histopath evaluation, do you record ovary and vaginal morphology so that you can assess cyclicity that way? Because you made a comment that you were unable to do it with vaginal swabs.
Mark Sesta. We do evaluate the ovaries. We look at the vagina. Yes, and the vagina. We can't get cyclicity data from that, but we can.
You can see if there's discordance.
Yeah, we can, look at the corpora lutea and the epithelium of the vagina and just see if they're actually, if there's any evidence that they're not cycling. But that's about the best we could do.
But just and another on study design, since CNS going into this study was a known potential target organ, I was curious as to why you didn't look at FOB measurements, just as a general tox assessment, particularly since this was essentially a juvenile tox type study.
Yeah, that was just something that wasn't added into the study design.
Other? Yes, Dr. Jones.
Dr. Sesta, you may answer this in your presentation, but you use a 4-point severity scale for your grading. And what would be your typical severity expectation for CPN at this age rats at 2 years?
We do use the 4-point scale. A typical, well, I will say that we saw a lot of grade 4s, especially in the controls, and that I think is a little unusual. I wouldn't expect it to be that severe unless there was an exacerbation. But there does seem to be some variability in this strain. So.
Okay. Thank you, Dr. White. There's a question. Niels?
Just a side remark. You tend to refer to the rationale for the low dose for the whole body average to the spatial peak limits, and I think that was not the real rationale, and that should be at least improved in the report.
Thank you. Okay, we will continue our discussion now on the rat study, looking at the pathology with Dr. Sesta.
Okay. Good morning. Seems we made it to the last presentation of the meeting, so I'll just get started. Today, I'm going to, first I'll briefly describe the pathology peer review process that we use for the chronic rat study, and then I'll switch gears a little bit and present some of the lesions. I've got 3 lesions in the heart that I'm going to present because that was a target organ. 2 lesions in the brain, the glial cell lesions, because that was an organ of concern in this study, and those were included in the partial report. And then I will present the chronic progressive nephropathy in the kidneys. But first, the peer review process. So just as a reminder, these are the steps in our just our standard NTP pathology peer review process, which were described very nicely by Dr. Briggs yesterday. But just to recap, we start with the pathology data review, or the PDR, where the data is reviewed to determine which lesions or organs need further review in the subsequent steps. The audit of pathology specimens, or APS, where we review the materials for quality, accuracy, and adherence to NTP specifications. And we typically review 10% of the materials from a study. After that, we have the pathology quality assessment, which is the first step where we're actually reviewing glass slides. And that is performed by the quality assessment pathologist with oversight from the NTP pathologist. Then we have the pathology working group. The purpose of the pathology working group is to review and confirm the treatment-related lesions from a study and resolve any other outstanding issues that need to be resolved. These typically require a full day. We also have the option, we don't always need to have them, but if we do, we have what we call a pathology peer review, or PPR. This is similar to a PWG, but typically we use these to address issues that are limited in scope or just individual issues that arise. So we have occasionally, for some of our smaller studies, we will have a PPR instead of a PWG, particularly if there's nothing, if there isn't much going on histologically. But more commonly, we'll have PPRs to address issues that arise after the PWG, or as a result of the PWG. Very often, the PWG will determine that in order to resolve an issue, further slide review is required, and will confirm the results of those slide reviews with a PPR. And for the chronic rat study, all of these steps were followed, but because of the release of the partial report, some adjustments were required. So we initially identified the proliferative lesions in the heart and the brain and selected those for early reporting in the partial report. So we did a complete review of these proliferative lesions in those two organs, including an APS. And for the APS, instead of doing the usual 10%, we actually reviewed 100% of the materials. A PDR, we did a QA and several PWGs, which I'll get into further. We expedited this review because of the potential for public health importance. And to do that, we assigned multiple pathologists. We had one QA pathologist for the heart and one for the brain. And then we asked them to do it very quickly. And I have to say our contract pathologist did a wonderful job in getting this done quickly and doing a very good job with these. So each of the QA pathologists ran their own PWGs. So the first two PWGs that were held were just part of the normal process. But during the conduct of these PWGs, it became clear that we needed more definitive criteria for some of these lesions, particularly the glial cell hyperplasia and the Schwann cell hyperplasia, and differentiating those from the neoplasms. So to do this, we convened two additional PWGs, and one for the brain and one for the heart. And for the brain PWG, we invited 5 external expert neuropathologists, including an MD pathologist with experience in proliferative glial cell lesions in humans. And for the heart lesions, we invited 5 external expert cardiovascular pathologists. And the results of the second 2 PWGs did confirm the results of the first 2 PWGs. There may have been 1 or 2 differences in diagnosis, but the conclusions were exactly the same. And we were able to come up with some definitive criteria for those lesions, which I'll share with you in the next part of my presentation. So after release of the partial report, the remaining tissues, including the non-neoplastic lesions or non-proliferative lesions in the heart and brain, were reviewed according to our normal peer review process. We did have several pathology peer reviews after the PWG to address some outstanding issues, and some of these issues included data from the partial report. But the bottom line is that all the lesions that were potentially treatment-related were reviewed by panels of expert pathologists, and the diagnoses and incidences represent a consensus of the pathology working groups. So we have a high degree of confidence in this final data. Okay, on to something a little more fun and interesting. I'm going to present the endocardial and myocardial schwannomas and the endocardial and myocardial Schwann cell hyperplasias in the heart, and the cardiomyopathy in the right ventricle, and then the malignant gliomas and glial cell hyperplasias in the brain, and the chronic progressive nephropathy in the kidney. I just want to make 2 quick points. First, the Schwann cells are support cells for the peripheral nervous system, and they produce myelin. And the myelin-producing cells in the brain are the oligodendroglial cells, which are a type of glial cell, but they have a very distinct morphology. And the morphology of the cells in these gliomas and the glial cell hyperplasias is very different. It's more consistent with astrocytomas or astrocytes or microglial cells. So we considered these independent lesions and did not combine them for our analysis. And the other point I wanted to make is that currently there are no photomicrographs in the draft report, but some of the photomicrographs I'm going to show you will be included in the final report. So endocardial schwannoma, these are our diagnostic criteria. They typically arise in the subendocardial region of the left ventricle, though they can arise in the right ventricle or even the atria. They are invasive. The cells have indistinct cell boundaries. It usually comprises 2 cell types, ovoid cells, which tend to be adjacent to the endocardium, and the more spindle-shaped cells. In my experience, the spindle-shaped cells are far more prevalent, and you don't always see the ovoid cells. The cells may exhibit some mild atypia. You may see mitotic figures, and you may see some palisading nuclei. So this is our standard section of the heart that we take for every animal in a study. We have the right ventricular wall here, identified by the RV. This clear space here is the right ventricle, and then the interventricular septum. The left ventricle is this other clear space with the blood in it. The left ventricular wall, which is much thicker than the right ventricular wall, and then the atria at the top. The endocardium, the endocardium is the lining of the inside of the heart, where the epicardium is the lining on the outside of the heart. And here you can see this area of blueness. At this level, that's about all we can say about it, but one of the first gross generalizations I learned in my pathology residency was that blue is bad, and that holds true here. It's kind of difficult to see, but you can see some more of this lesion as it extends down along the endocardium all the way down to the apex of the heart, which is the pointy end down here. So we'll zoom in on this blue lesion. And you've seen this picture before, but I'll give it some explanation. So here in this area, the subendocardial region, we have a lot of dark blue cells. We'll take a closer look at those later. You can also see more easily the extension of this lesion here and even out into the myocardium. So it appears to be invasive at this point. Here's a little bit higher magnification of these cells, and I will move to the even higher magnification. Here you can see most of the cells in this field are the spindeloid type, and you can see the indistinctiveness of the cell margins. You can't really tell where one cell ends and the next one begins. So that's all very characteristic of an endocardial schwannoma. Myocardial schwannomas, these are often less cellular than endocardial schwannomas. I should say that the cellular margins are indistinct. The lesion margins are irregular, but I wouldn't say they're indistinct. These are composed of loosely arranged spindle-shaped cells. We don't really see those ovoid cells. Mitotic figures and mild cellular atypia may be present, and you, as with the endocardial form, you might see palisading nuclei. So here, this is a myocardial schwannoma, and first I feel I need to explain why this looks more like a flamingo than a heart. So we take that standard section for every animal, but if there's a gross lesion, visibly gross lesion in necropsy that's not captured by that standard section, we will take a separate section through that lesion, and that's what happened here. You can see this bulging surface on the epicardial surface here, so this lesion would have been visible grossly. So a separate section was taken. And here you can see these bundles of neoplastic cells tracking through the myocardium. These darker pink cells are the myocardial cells. And even like here, you can see some early palisading. Palisading nuclei are just when the nuclei of adjacent cells line up, and that's starting to happen here, over here. And then looking closer at the cells, you can see that these are elongated or spindeloid, and the cell margins are very indistinct, and they have pretty abundant eosinophilic cytoplasm. So on to the Schwann cell hyperplasias. These are similar to the schwannomas. The endocardial form is very similar to the endocardial schwannomas, and the myocardial hyperplasias are very similar to the myocardial schwannomas. But these are less extensive than schwannomas, as you would expect. These are non-invasive. There is no cellular atypia, and mitotic figures are pretty rare. So here's another of our standard sections of the heart, and I would be very surprised if anyone could actually see a lesion here. I know where it is, and it's difficult for me to see. But we're going to focus in, if I can get my little, there we go. We're going to focus in on this little tip right here. So here you can see the tip of this point here is there's some subendocardial thickening by population of cells, maybe a little bit more over here, and we'll take a closer look. So here you can see these cells with indistinct cell margins, small dark nuclei, somewhat similar to what we saw with the endocardial schwannoma, but much less extensive. Cardiomyopathy. Cardiomyopathy is a very common background lesion in rats that can be exacerbated by treatment. It's characterized by degeneration, necrosis, or loss of cardiomyocytes. You often see mild inflammation, most commonly the mononuclear cell type, macrophages and lymphocytes, but you may also see occasional neutrophils. And later in later stages of the disease, you see some fibrosis replacing the lost cardiomyocytes. And in this study, in the right ventricle, it was most prominent in the subepicardial region in the lower half of the heart toward the apex. So this is not the right ventricle, this is the left ventricle, but you can see all the features that I just described here. So these are more normal cardiomyocytes, and in here you can see cardiomyocytes with large vacuoles, and these empty spaces within the cardiomyocyte itself, and many of these are shrunken and small, and so these are degenerating cardiomyocytes. You also see a number of mononuclear inflammatory cells, all these cells with the dark blue nuclei. And you may even see some early fibrosis here. It's not very well organized at this point, but there may be some early fibrosis replacing some of these lost cardiomyocytes. So in the right ventricle, this is the interventricular septum over here, and there may be a few lesions, but we're going to focus over here on the right ventricle. And these arrows are identifying regions where there's loss of some cardiomyocytes. And again, here's a normal right ventricle for comparison, but over here we see some shrunken cardiomyocytes here, and it's a few inflammatory cells scattered throughout here. And this was pretty typical of what we saw in this study for cardiomyopathy in the right ventricle. Obviously, some of the lesions were more extensive and extended farther down into the myocardium. Other animals had more foci, but this was fairly typical of what we saw. So onto the brain, just as a reminder before I get started that we now collect, and for this study, collect 7 sections of brain as opposed to 3. So the malignant gliomas, these are usually, as you would expect, larger than the glial cell hyperplasias. These lesions have indistinct cell borders. The cells are very pleomorphic and densely packed, and the cell density is one of the features that we use to differentiate these from hyperplasias. You often see perivascular cuffing where the cells cluster around blood vessels. You may see satellotosis where the cells, the neoplastic cells, aggregate around neurons. You may see meningeal invasion and a few mitotic figures. So here is a rather large neoplasm occupying roughly a quarter of this section of the brain. And there's also some tissue destruction down here caused by the neoplasm. This neoplasm was large enough that on the next adjacent section we could still see it. And here we can see it's still rather large as well. And you can see the indistinct margins of this lesion. You can't really tell where it ends. You know, you just see fewer and fewer cells the farther away you get. And at some point, there's where that last cell is hard to tell. So this right here's the perivascular cuffing, which I have higher magnification of. Here you go. You can see these neoplastic cells clustering around the blood vessel and up here as well. And here, I have a higher magnification. You can see also the pleomorphic nature of these cells. Some are a little bit larger and have more cytoplasm with slightly more open nuclei. Some are smaller and have darker nuclei and less cytoplasm. That's very typical of these neoplasms. And here's an example of meningeal invasion. We have the leptomeninges out here, and these neoplastic cells are just invading through the meninges along the surface of the brain. Glial cell hyperplasia, these are similar to malignant glioma, except that they're usually smaller. There's no meningeal invasion. Meningeal invasion is indicative of a neoplasm. The cell density of these is low. You may see perivascular cuffing, but if it is present, it's very minimal. And there are generally no mitotic figures. Also, there are no reactive or degenerative or necrotic elements within the associated parenchyma. Glial cells, if there's a necrotic area in the brain, glial cells will react and migrate in to clean up that area and participate in healing. And we don't, that's not a neoplasm, so we want to make sure we differentiate this hyperplasia from what we would call gliosis. So here's a section of the brain through the caudate putamen right here. And I don't know if you can see the lesion. It helps. We often had to compare one side to the other. But there's a lesion right there. And I have a little higher magnification. There you can see an increased number of cells, but it doesn't appear to be any destruction of or damage to the tissue. And looking at higher magnification, here you can see, again, the increased number of cells and the pleomorphic nature of these cells. They're very similar to what we saw in the neoplasm. And just to compare the density of the cells, here this is from the section that I just showed you, and this is from the same section of brain, but on the opposite side that didn't have the lesion. And this is from the tumor that I showed you earlier. So you can see the difference in cell density between these lesions. So on to the kidney, the chronic progressive nephropathy and the related lesions. As has been mentioned, this was considered the main reason for decreased survival in the treated groups, or sorry, the control group. There were numerous lesions with decreasing incidence and or severity, which are listed in the report. I'm not going to talk about all of them, but I already touched on this. So the parathyroid gland hyperplasia, fibrous osteodystrophy, and the mineral and numerous organs, those are directly related to the chronic progressive nephropathy as a result of perturbations in calcium and phosphorus balance. But then we also had which I mentioned, the increase in severity of the polyarteritis nodosa, that correlated with the increase, or at least there was the increase in severity followed the severity of the chronic progressive nephropathy. So this vascular inflammation can decrease blood flow to various organs and cause a number of secondary lesions, such as necrosis or degeneration, ulceration, atrophy, which are all listed in that table. So there are a number of features of chronic progressive nephropathy. I'm not going to read through all these. I'll just show them to you. So here we have a grade 4 chronic progressive nephropathy from one of the control animals, and for comparison, a grade 1 from one of the mid-exposure animals. And you can see in this grade 4 there's hardly any normal tissue left, whereas in the grade 1 you can barely find the lesion at this magnification. But here is the lesion. And here we have a number, there's a number of dilated tubular profiles here with this eosinophilic material, which we call either protein casts or hyaline casts. And then if we look over here, we can see, it's kind of difficult to see, but these tubules are much smaller, and the cells lining them are sort of basophilic or blue, and they're smaller and they're more crowded together, indicative of regeneration. You can have just necrosis occur in the odd tubule now and then, and you will see the cells regenerating. But what's different here from that is this eosinophilic material surrounding the tubule, which is the basement membrane material. So we see this thickening of the basement membrane that does not occur in just normal regeneration. That is, when we see that, that's indicative of chronic progressive nephropathy. And to look at point out these normal glomeruli, you have nice urinary space here around it. There's red blood cells in the capillaries. Note the level of the amount of pink material in here, the mesangium. I'll compare that to this. So this is the grade 4. You can see there are quite a few dilated tubules here with a lot of the hyaline casts. You see these shrunken atrophic tubules with proliferating tubular epithelial cells, and the thickening of the basement membrane around these tubules. There's also a lot of inflammatory cells scattered throughout here. And then in the end stage, the glomeruli become affected. And you can see these here, you can't really see the urinary space, and there's a lot more of the mesangium within the glomerular tuft. So you can tell, I mean, this animal, I don't know if this one was one of the early deaths or not, but it certainly, if it did survive to the end of the study, it didn't feel very well. So that's it. And if you have any questions, I'll be happy to answer them.
Thank you. Questions from the panel? Yes, Dr. Kaufman.
Wolfgang Kaufmann. I just saw the images of the brain and the malignant glioma and also the clear cell hyperplasia. I wonder what about the criteria in some way. When I listened to you, I had the feeling that the hyperplasia was more a tumor-like lesion than a true hyperplasia. What I understand with hyperplasia is that it is not a truly independent growth. And when I observe a tumor in the brain, and this would be more in that kind of direction. And the similarity between the glioma, and I thought this is a very important remark, what I did not find in the report, that it is more an astrocytic-like change. Because when I looked to the public comments, the myelin was considered a focus in some way. And we have to know that we have, maybe the other gliomas, I don't know how they look like, but if they look like these, then we have no oligodendrogliomas, so we have no tumors of the myelin producing glial cells. So this, I think, should be clarified in the report, or should be added from my point of view. And I just worked on the in-hand nomenclature where we considered about the criteria of brain tumors. And we came to the conclusion to take the evaluation of the human classification of low grade and high grade. For me, when I see this kind of change in the brain, would be a low grade glioma and astrocytic type, but this is according to these kind of criteria that was brought up and published. And I just wanted to know what the base of the diagnostic term glial cell hyperplasia is. Is it triggered by maybe human lesions, human pathology lesions more, or is it a traditional term that is used to differentiate against gliosis? What I think is important, yes.
Yeah, that's a very good question. The term glial cell hyperplasia, I'm not aware of any lesions in humans, hyperplastic lesions in humans, but and you know the issue of high grade versus low grade was discussed in our PWGs, but I'm not exactly sure where the term came from. It was diagnosed by the study pathologist, and we did have this extensively reviewed in our PWGs, and our expert panel did agree with our diagnosis. But as for the exact origin of the term, that I'm not sure of.
Just one additional question to this. Did you consider ever some kind of special stage, immunohistochemistry, where we can differentiate the one other type, or can look to it? I mean, that is also controversially discussed. You see no GFAP staining, and this would be a point to also to differentiate between neoplastic and non-neoplastic change.
Yes, we have talked about that. We do have some plans to investigate these further, but exactly, I mean, we're limited in how much tissue we have, so we have to decide which direction is best for us to evaluate these, whether we do something with molecular pathology techniques or immunohistochemistry. We're still discussing that, but we do have plans.
Dr. Adler?
Rick Adler. So I have questions about the heart. So if other panelists want to continue questioning about the brain, I'll defer and let us stay on the same theme.
Dr. Malarkey and then Dr. Lin.
Dave Malarkey, NTP. Dr. Kaufman, we agree with your concerns about the differentiation of these tumors. Most of them were poorly differentiated. We didn't see the astrocytic component, or it wasn't agreed upon. And oligodendroglioma we hadn't seen either. So if you see both of them in a tumor type, we call it a mixed malignant glioma. So, and we have ongoing studies to look at the immunohistochemical properties of these lesions. And the hyperplasias were small nests of cells that, yeah.
Just an additional questions. You had a peer review with 5 neuropathology experts, and one of them was a medical pathologist. Did glioma mixed in rats are not really very similar to glioblastoma multiforme in humans, but they are going in some kind of that direction. What did he comment on that, if that is?
Yeah. Well, what I recall is that we did have some examples of that in our meeting from another study, glioblastoma multiforme-like. So, and he would agree that would be a glial tumor, and that's more the humans to get that. And so we weren't seeing that in this study.
Dr. Lin and then Dr. Adler. Dr. Lin, did you have a comment?
Yes. I understand that altogether 7 sections were taken from the brain. I wondered if one or more of those sections that went through the auditory nerve or the 8th cranial nerve. I asked that question for a number of reasons. First of all, you had actually said, and many other people have said, going into the investigation, one area of some substantial interest is brain tumors. Therefore, you had some focus on that. Of course, there were 3 types of brain tumors that was identified in the human population. Glioma is one of them. Meningioma is another one. And the third one is the acoustic neuroma. Of course, it was kind of surprising to me, I think to some people as well, as what you found in the heart, the schwannoma. As you know, there's considerable similarity between the schwannoma in the heart as well as the schwannoma or vestibular schwannoma in the along the auditory pathway, essentially. So I wondered not only whether you had sections that went through the 8th cranial nerve, and also have you actually paid any specific attentions on what you might find if you look into the sections where the auditory nerve was visible.
We didn't look at the. I don't think that I'm not sure. Do our sections go through the auditory nerve, Dr. Sills? No. So, but we did not see any lesions in the brain that had the morphology of a schwannoma or an auditory or vestibular schwannoma. So, does that answer your question?
But if you had not seen or did not have a section that went through the auditory nerve or 8th cranial nerve, then it would not be so easy then to really observe any possibilities or any pathologies in that particular region, would it?
Yeah, I mean, we didn't look specifically at that at the auditory nerve, so Yeah, if there was a small lesion there, certainly we wouldn't have seen it.
Yeah. It would seem to me that the study team would have the a priori knowledge that acoustic neuroma or the vestibular schwannoma was part of the findings in the humans. Then the question that rises in my mind, why that issue was not investigated.
So I could help.
Could you identify yourself, please?
Robert Sills, I'm the chief of pathology. And so one of the things we do with our studies, we do a comprehensive evaluation of the nervous system. So we look at the central nervous system, the peripheral nervous system. We look at all the nerves within the animal. And so as we look, for example, the brain, there are cranial nerves in the brain. There's the acranial nerve. There are nerves that deal with the auditory system. And so if there was any indication that those nerves were involved, we would have picked it up. So to answer your question, we do a comprehensive evaluation by looking at the entire nervous system. The schwannomas are clearly very comparable to the acoustic neuromas. So they're schwannomas. We had malignant schwannomas. We had Schwann cell hyperplasias, and all those tumors are consistent with what we see within the humans. They're all schwannomas. Thank you.
So you're saying that you did at least do a general survey, so you did take that part into consideration?
Yes, and what Mark said, we also went back and we looked at the whole neck area. Mark did a comprehensive evaluation because of this, because of the issue of the acoustic neuromas. So we did look at it. We did consider that in our investigations. Thank you.
Dr. Adler?
Rick Adler. So a question now about the heart. I'm flagged by the incidence of right ventricular cardiomyopathy. And I'm comfortable in short-term toxicology studies that the left ventricular wall is more commonly affected with this. And so is it also true for 2-year studies in NTP's hands that the left ventricle is more the predominant site of spontaneous cardiomyopathy? You're nodding, but that's not going on the record, so I want you to verbally say, yes, that's true.
Yeah, I mean, it's certainly more prevalent and more obvious in the left ventricle.
It does occur in the right, but this study brings out there's a preponderance of right ventricular cardiomyopathy occurring in males and also in females, which females tend to not have the spontaneous disease that males have. So is it fair to conclude, maybe it's not as clear in the report as I'd like it to be, is it fair to conclude that radiofrequency radiation is related to that lesion, or the lesion is related to RFR, is responsible for it, has induced it? It's not typical of a spontaneous disease in the rat.
I mean, if we applied the criteria to non-neoplastic lesions, I would say it's equivocal. There was a slight increase in the incidence, maybe a slight increase in the severity, but overall it was it wasn't that severe a lesion. And if we looked at the entire heart, we would have lost. We wouldn't have seen any effect at all. So it was a minor component of the cardiomyopathy.
Well, I guess
when we compared the right ventricle in the treated animals to the right ventricle in the controls, there was an effect.
There is an effect.
When we compared the rest of the heart in the treated animals to the controls, there was no effect.
So is it also true that there's also an effect when you compare to historical control data? There's a right ventricular effect.
We don't have any historical control data for right ventricular cardiomyopathy.
So it's relative to literature then. Is there any association spatially with malignant schwannoma and the right ventricular effects?
Yeah, I looked at that and I did not notice any sort of association there. There were some lesions, the neoplastic and hyperplastic lesions in the right ventricle, but they were also in the left ventricle and even the atria. So I didn't notice any consistent patterns.
Okay, I guess I would add in my own comments later that I'd like the report to also show where those associations were not found, those spatial associations, because these are very important avenues, and I'm obviously not the first pathologist to look at this and not the last to think the same way, that mechanistic insights come from these kinds of associations, and it's very important, I think, that the report bring those out, where they were found and where they were not found.
Mm-hmm. We can certainly add that.
Thanks.
Dr. Rinke, and then Dr. Whitley, and then Dr.
Yeah, I just can support what Rick Adler said. I was having the same question when I read through the report, seeing that the right ventricular infiltration was highlighted somehow. And the question would be the same for the endocardial schwannomas or hyperplasias. And you answered it, it is not that there was a certain distribution, but usually the schwannomas occur in the left ventricle, and it's really rarely that they occur, at least to my knowledge, what I know from Wistar rats, that they are not so frequently seen in the right ventricles. And according to that, also the question, did you perform any immunohistochemistry on the schwannoma lesions?
No, as with the brain lesions, we have plans to explore these further, but we haven't done anything to this point.
And another question, were there any incidences or increased incidences on metaplastic lesions in the heart, like chondromatous or osseous metaplasias?
No, there wasn't.
Okay.
So just a little bit of a follow-up on the way this is written. So the description of the schwannomas appeared to me to be like a textbook description around maybe frequently have, and not specific to this study. And so I'm just, is there anything unique about the schwannomas morphologically where one of the features was more prominent in these relative to the textbook type descriptions? And so this just goes with then clearly just defining associations with cardiomyopathy.
Yeah, no, I didn't notice anything unusual about these. They were pretty standard, endocardial and myocardial schwannomas. And then, yeah, the association with the cardiomyopathy, we can write more about that in the report.
Dr. Andrews-Jones.
Lydia Andrews-Jones. I actually have two questions, and the first is you mentioned that typically the cardiomyopathy is seen at the apex, but the example you showed was kind of more mid-right ventricle. Was that just happened to be the example, or was there a spatial irregularity, so to speak, or atypicality?
No, I mean, they tended to be more towards the apex, but not all of them were. There were a few higher up as well.
And then the second point I have, this is more directed at you, Dr. Sills. In hand, it's my understanding that glioblastoma is a diagnosis reserved for humans, and that we do not use glioblastoma multiforme in rodent lesions. That's correct?
Rick, regarding your comment about historical control data, we have a wealth of information on the F344 rat, but we don't have many Sprague-Dawley studies. But they're coming through now, and so we're going to look at their hearts for this, to see if there's a right-sided preference in the strain of rat.
Well, we haven't seen in Harlan Sprague-Dawley's or Sprague-Dawley's in general, we haven't seen right ventricular preponderance in shorter-term toxicity studies. And I guess I wouldn't expect a strain difference between Fisher's and Sprague's in terms of cardiomyopathy, because it's a disease of ischemia. It's not a disease that's particularly strain dependent. It's a catecholamine, we believe catecholamine ischemic mechanism, and unique spontaneously to male rats, suggests a specific susceptibility. So I wouldn't expect to see a strain difference.
But we could check that.
Yeah, I think that would be worth publishing.
Go ahead.
So could you hear me now? Yeah, Robert Sills. And so Lydia, to answer your question, in this study, they were called malignant gliomas, and so the panel on the PWG review, it consisted of a number of people who were on in hand, and the bottom line was that these were malignant gliomas. So to further answer your question about glioblastoma, I think the biology of what these tumors mean in terms of humans or in terms of just malignant gliomas, there's a lot of information coming out now in terms of molecular biology that probably will help us understand these tumors much better. I think, for example, human brain tumors, a lot of the characterization is based on molecular endpoints, and that's one of the areas that we will be pursuing in the future. It will be interesting. Some of these tumors may have molecular characteristics of glioblastoma. We don't know, but it's something that we plan to follow upon. Thank you.
Thank you. Dr. Harkema?
I'm still just a little bit confused with the variability of the right ventricular lesions. So would you show more epicardial? Could you just describe of all of them where they were within the right, where they were all over the place? You said more in the apex, but were they these more epicardial?
They tended to be in the subepicardial region, and in the more severe cases, it did sort of extend down into the myocardium a little bit more, but they definitely tended to be subepicardial.
Okay, and then just to reiterate what was already asked, those are really rare, right? Okay.
Yeah, and we've never, pulled out the right ventricle like that before.
So when you, now, and this is just procedure now, so when you have something like that and you wanted to make sure that you don't have it, you haven't missed it just because of the cut or something like that, what would be the procedure then that you would follow so that you would get more, you look at more of the heart? Or not? Or
If we have a heart that doesn't have it, would we take more sections to see if it's there?
Yeah.
No.
Okay.
We treat every heart the same. So, that, yeah, we just treat every heart the same.
Okay.
Dr. Klein?
I just wanted to comment a bit on the, and ask a question on the chronic progressive nephropathy, and I think it relates also to nonlinear dose response curves for multiple outcomes. Did you guys consider the possibility of a hyperthermia effect independent of the radiation effect? At the highest dose, you have got an increase in body temperature, and that could result in induction of heat shock proteins and other molecular mechanisms that might be relevant to chronic disease.
To the, specifically to the...
I'll say kidney.
Okay. So, no, we didn't look into that really. The testes, which are, one of the more sensitive organs to heat, there was no effect there. So, we didn't really look into that any further.
Yeah, I'm not talking about a damaging level of heat, but rather a heat shock protein molecular chaperone inducing level. That just might be an interesting mechanism to pursue if you want to explore the effects further.
Yeah, no, we didn't look into that, but I agree that might be an interesting thing to look at.
Dr. Lin?
Just in response to the Dr. Klein's comment, of course, hypothermia, backdrop, let me see. 1 degree Celsius rise or fall in body temperature is generally considered in the normal physiological range. When we wake up or when we go to sleep, the temperature variation is greater than 1 degree C. Therefore, that by itself should not be a matter of concern. And coming back to hypothermia, one normally would not classify a 1 degree temperature rise as in the hyperthermic range. That, in other words, 37, 38, 39 degrees, even 39 degrees is not normally considered as a hyperthermic rise in temperature. It will have to be above 40 degrees or so. As far as the heat shock protein is concerned, I think the literature does not suggest necessarily that 1 degree temperature rise would trigger the heat shock protein.
Yeah,
Dr. Barnes.
I just comment along the same line. There's old data that shows that you can get stress proteins or heat shock proteins with very low levels of exposure that are, below 1/10 of a degree. So that some of that literature exists out there. Now, how relevant it is to this is, I don't know, but certainly there is some data to that effect.
Dr. Harkema.
We'll get more into this, probably into possible mechanisms and everything, but I think you would agree, Dr. Lin, that different organs respond differently to different heat increases. So the potential of the heart reacting differently than the testis or whatever, that might be a difference.
Surely, I duly appreciate the fact that different organs. The example has been used with the testes, for example. The skin is another one, of course, that has a different temperature sensitivity. But as far as the variation among various organs in response to temperature elevations, again, I think what normally is considered a greater than typical temperature rise is not a temperature range that is well within the diurnal temperature variation. So in that case, if that's the case, of course, that all of us, by engaging in rigorous exercise, will be subjecting ourselves to a hyperthermic influence. And perhaps, if one wishes to, could interpret that as deleterious. Certainly, I don't suggest that's the case. I don't think that is the case.
Thank you. Dr. Kuster.
Yeah, that was also an issue when I was looking at the data. We're doing a research on RF hypothermia as well. And we need to be aware that we only have information about the whole body temperature increase, or indication of the whole body temperature increase. We do not have much information about the single tissue temperatures, which might deviate from the whole body. And in view of that, and waiting that the highest group is not a linear response throughout up to the highest dose. Some of the data you had a small drop, and that was indicated as that we don't have a dose response. But in view that we cannot exclude mild hypothermia in the tissues, I think that is kind of a stress to weight the data that way.
Dr. Mangiaros. Oh, yes, sir. Come here.
This is Gonçalo Gamboa, FDA. I would say that we need to be very cautious about what we call here. I mean, I would not call the data that we have whole body temperature. What we have is subcutaneous temperature, which may be entirely different from the core temperature that is attained inside the rat. I mean, subcutaneously, you dissipate it much faster. Remember that these data were acquired within a period of up to 3 minutes after stopping the irradiation. So we truly don't know how hot the heart got. And so I think that we need to bear that in mind. We're dealing with a set of unknown circumstances here. Thank you.
Yeah, my name is Kevin Modest with the California Brain Tumor Association. This was supposed to be a peer review experience with people expert in EMF exposures, and it seems like the peer review here is people who are expert in chemical exposures. And I communicate regularly with 220 scientists who really identify as EMF experts, EMF scientists, and none of those scientists are part of this review panel. And this is a issue, this study is a critical issue because we're about to embark on 5G, which is going to expose people to very high intensity wireless radiation. 24 gigahertz to 90 gigahertz, and now they're talking about going over 100 gigahertz and putting it near every family, every child here. So I ask that this panel recuse itself and reconvene when we have true EMF scientists, EMF experts, not chemical experts, to consider the data, the meaning of it, and especially given that this study was released early because of the very strong concerns regarding brain cancer, and that unfortunately there's been changes in the program here and things, and we've backed off of the brain cancer and just focused on the heart cancer.
Do you have a question for the panel?
Well,
if you don't have a question, I think it's probably time
Okay, my question is, why won't you recuse yourself? Because lots of you know that you're not expert in this field, and what strikes me is that the experts on the public side, Dr. Blackman, Dr. Melnick, are not on this panel, and you all are.
Please. These are
And this is of the
pathology.
utmost concern.
These are pathology studies, sir. These are pathology studies, and we have some of the best animal pathologists in the country here. So they do have expertise. Okay, we have to bring this to a close. Dr. Milnick, very quickly.
Look at emfscientists.org, and you see all the scientists that are expert in this field and are being left out on purpose. And this is the
Please, we've heard from you, sir. Enough.
experts away from the
Enough.
So I have two questions and one comment. One is the hyperplasia severity varied among the rats, the glial cell hyperplasia. The slide that you showed us, what was the severity grade? Because they did vary up to 4, and I think it would be informative. If you showed the 4, that would be fine. But if you didn't show the 4 severity for the panel to see what a 4 looks like next to a tumor. That's one question. A comment on the right ventricle cardiomyopathy, you indicated that it wasn't very severe, but on some of the individual animal pathology reports for cause of death, it is listed as cause of death or contributory cause of death for approximately 20 animals in the CDMA exposure group, mostly at the 6, but also at the 3. So that's a comment. And the third question is, you picked up a schwannoma because you saw it visually at necropsy. Why don't you cut additional sections to see if you missed any schwannomas in the heart?
Well, as far as the grade of that hyperplasia that I showed you, unfortunately, I'm not sure what the grade was on that one.
Can you judge?
I could say it was not a 1, but that's as far as I'm willing to go at this point.
Well, can you show a 4 to this group after coughing?
I don't have one with me. I mean, I might be able to go get one, but I don't have one on hand. Okay. And as far as the what was the other question? The
cause of death.
Cause of death. Yes, we noticed that also. Actually, our one of our contract pathologists, one of our reviewers, noticed that a lot of the some of the causes of death were attributed to the right ventricular cardiomyopathy, and he did not agree. And so we had a preliminary review of that done, and so we don't have a lot of confidence in that cause of death assessment. That's a very subjective assessment. So we're going to look into that further and see.
The third was additional section of the heart.
Oh, additional sections of the heart. Well, we don't take additional sections of the heart. We try to treat every heart the same way, so that we have consistency and you know, we avoid bias.
Yeah, I understand that, but on kidney issues, when there were tumors in the kidney, the program increased the number of step sections to see if they missed something.
Well, with the kidney step sections, that's a separate study.
I know it's a separate, but
Yeah.
it's the same concept of additional sections to see if you perhaps missed some of the tumors.
Yeah, no, we didn't do that for this study. We didn't do heart step sections.
I have a very brief.
Dr. Davis, this
Yes.
is a question to Dr. Sesta relating to pathology, correct?
Yes, it
okay,
is.
keep it to
Okay.
that, please.
Specifically, on the impact of the 28-day studies, you noted before, adenocarcinoma, mammary adenocarcinoma presenting, just at the end of that. And I want to ask you about whether you think there might have been consistent perinatal effects that would be expressed now later on. Specifically, your table H2, which looks at tissue evaluations in the male rats, and H1, where there is a summary of the epididymal spermatozoal measurements. And I'd like to ask the statisticians why they didn't do a Williams or Dundas test. It looked to me like this is a significant pathological impact. And I just want to raise the question, and I'll share these with you, where I've marked where it looks to me like there is statistically significant declines. And let me just add, as Dr. Barnes has repeatedly said, the lack of linearity here, the lack of monotonic response. As you know, it doesn't mean that you don't have a dose-response relationship. It just can be a different kind, shape of curve. It doesn't have to be linear. So I'll leave you with these specific comments I have written up here about the pathology, and just would appreciate your clarification, because if you had some protein insufficiency early in pup life, that has lots of effects. And if that combines with RF exposure to give you increased pathology, whether it's mammary, testicular, or otherwise, I think it's important to note that.
So, Dr. Shockley, would you like to comment?
Yes. So I'm going to table H2 in the report, and I'm looking at the epididymal measurements that you're referencing. And you asked why we did not conduct a Williams test for trend. And so it does look like the numbers show a trend, but as the footnotes indicate, we did conduct those tests, and it wasn't significant. And the reason why, if you look at the this 6 watts per kilogram group, there is a large uncertainty associated with that, and so it didn't pass the statistical filter.
But we would agree that that in many cases, statistical significance may not be the same as public health importance. And you have a suggestion of a trend. I agree, it didn't meet the significance there, but it still might be worth taking note of in the revision that you're going to be doing. I'll give these comments to John so he can take a look at them.
Appreciate it very much,
Thank you.
Dr. Davis.
Okay, we are going to take a shortened break, because I want to make sure that we have plenty of time for our panelists.
Could I make a brief comment, please?
Oh, quickly, please.
Just on the record, in response to the gentleman from California, maybe I'm a bit modest if I make the statement that I am going to make. That's personally, I do not take a second seat from anyone in this room regarding the biological responses to RF radiation.
Thank you. In the order that is on the agenda, at least that I have, and the same procedures as yesterday. We'll have a presentation from the peer reviewer, and then the panelists may ask questions of that peer reviewer. Dr. Filter, I believe you're first on the list.
Okay, thanks. So I'm going to go through my comments pretty much in the order that I submitted the written comments, but I do have some changes in what I'd like to focus on. And I'm going to try to stick to what I think are the most important things. I think it's really important to have an in-depth discussion that a layperson can understand to the best extent possible about the dose metric of watts per kilogram and the importance of understanding SAR sensitivity. I actually don't think SAR sensitivity, I look for that phrase, and I don't think it shows up in the report. So you have to go back and read the manuscripts that were underlying all of the dose metrics to understand that. The presentations the first day were excellent. I came away with a much better understanding of SAR sensitivity. It is super important in terms of understanding the dosimetry to the pups, which when I read the report without having that context, I was really confused. So I would really highlight that. It's also really important, the SAR sensitivity, to the extent we can, to make some comments about what does it mean if you see the most homogeneous SAR distribution at 900 megahertz in a rat and 1900 megahertz in a mouse. What does this mean for a 70 kilogram human where the homogeneous SAR is going to be at, from what I understand, a much lower frequency? And does this mean that we should not be interpreting the results of a certain frequency with a certain power administered to a rodent directly to a human? And that's one of my biggest concerns, is that the data will be misinterpreted. And we've heard a couple of times that the low dose chosen here expressed, and I understand why, it's very complicated, expressed as 1.5 watts per kilogram, is close to the FCC limit of 1.6 watts per kilogram. I'm not convinced, based on the complexities of what I've heard, that this statement is an appropriate one to be made, because what is important is the target organ SAR, not a 1.5 or 1.6 watts per kilogram SAR. And I don't think we know enough, or at least I don't feel like enough was presented to make a statement that the low dose here is related to the FCC limit. So I think that's a really critical point. I'd like to see a little bit more discussion in the report about what does the increased in pup mortality mean, and if that was, and you provided some additional context today that was helpful, but I think it would be helpful to have in the report as well. For survival, we've talked a couple of times, so it's already been acknowledged, but for the record that the survival was lowest in the high-dose CDMA males up through week 92, and it didn't switch over until after week 92. So I think it's a little inappropriate to just say that survival was longer and have that as a flat statement. Regarding the interpretation of the tumor findings, there's a statement in the bioassay, and I do not disagree with it. It says that 2 years there were similarities in neoplastic and non-neoplastic responses between modulations. I don't find that surprising, and I think it contributes to a recommendation that we heard, that at least qualitatively we consider the evidence in totality and not just individually. And I think that that has some important implications for, especially for the findings in the female rats where there's no evidence, but if you actually look at the data, there are some findings that are consistent with what we see in the male rats. They just don't rise to the level of statistical significance. But in my mind, for biological plausibility, this is where I was going yesterday with the liver tumors, but in an opposite direction. I think there's a biological plausibility that is sufficiently high that even though there's not statistical significance, that they should be included. And I think this will come up again later today. And that's true for both the heart and the brain of the female rats. And at the very least, I think there needs to be a really thorough discussion of them, regardless of whether there is a statistical significance. Given the challenges that you've had with the design and interpretation of all of the data, and I commend the NTP for taking on this amazingly challenging project, I would include all information that might be illustrative, or if you don't think it's helpful, say why not. So I brought up yesterday the issue of time to first tumor, and there's watch outs for that. If you don't consider it to be informative, then I would state that. But given the challenges we have with historical controls, I would at least be looking at it and considering it. And for me, I thought it might be another piece of evidence for the malignant schwannomas of the heart when I looked at time to first tumor. And so I would encourage you to look at those, especially for the key target organs. Let's see. I want to skip through some of the other things I think other panelists will also talk on. One of the things in the background of the report that I think is really important is that there are statements made about cell phone RFR that don't have context to them, as if a certain property is inherent to cell phone RFR. And I'd make the same comment about chemical toxicology as well, but I think it's equally important for RFR. So I think the conditions under which a finding was found, the doses or other conditions, are critically important, and things should not be stated as they are a quality, an inherent quality of RFR. And that includes other studies with or without cancer findings as well, right? Those findings are unique to the conditions of that study, just as NTP always states the same for an NTP bioassay. I think my other points are sufficiently minor or otherwise documented that I'll stop there and see if there's any questions from NTP.
Okay, Dr. White? Yes, are there questions from the panel for Dr. Felter? Dr. Lin?
I would just like to make a comment in response to what we have just heard. Another parameter that has been repeatedly referred to is the whole body SAR. Not, of course, the 1.5, 1.6 are both referred to a whole body SAR. I think we may all recall it's been repeatedly stated by NTP-related staff. What that means is that everywhere in the body is 1.5 or 3.0 or 6.0 watts per kilogram. So take those words into account. Then basically what that says is that in the brain, in the gut, even though they are separated by some distance, it is still 1.5, 1.6, or 2.0, 6.0 watts per kilogram. So the point of whether in a given organ is the same or not is another issue, separate issue. But that's a statement that has been used. That was the premise for the design of this study. So I want to emphasize that point. I have some comments to make later on regarding that. Regarding the time to tumor issue, I think it's relevant one. On the other hand,
can we address that like one before we get on to too many?
Let's go ahead, Dr. Adler, if you want. Looking at
I just want to I just want to make sure there's not a disagreement here. So that's really why I was raising the question of the dosimeter, because I think we heard from day one that the exposure to all of the target organs is not going to be the same, and the SAR sensitivity is going to be different, and things like electrical conducing properties of tissues are going to impact those. There's all kinds of things that are going to, right? And so I just wanted to make sure that I didn't misunderstand that you were offering a different interpretation of what I said.
Okay. You recall my emphasis was it's been repeated by several people associated with the NTP. This is what they said. But you may also recall I said I do not like the round bottle phantom model for animal body. And there's there's actually a disagreement between what I said and what the NTP associated staff said. I'm just repeating what the NTP staff has said. Yeah, so I take their word as a whole body exposure. Therefore, later on, I'm going to make, after this had done, I have some comments to make relevant to that, but that's something later on. Coming back to the point you had regarding time to tumor, I think this is obviously a relevant one. On the other hand, a tumor is a tumor. Doesn't matter when it is developed in response to the exposure.
So, Niels.
Niels Kuster, just to say it again, so the dosimetry is based on the numerical animal model. Has nothing to do with the bottles. The bottles were only used for validation. And you're right that not all tissue are exposed to the same level, but we did everything to have it as close as possible, and that all tissues are exposed to approximately the same level, and we know throughout the lifetime what the exposures of the different tissues are. That counts for SAW, it counts for E field, and it counts for H field. What I mentioned before, how it translates to a thermal dose, that is another question which has not been fully addressed. So that's why we cannot exclude that some tissue might experience mild hypothermia. The highest dose, at the mid and lower dose, there won't be any mild hypothermia.
Other questions for Dr. Felter from the committee? Dr. Adler?
Well, just to provide some more context to Dr. Lin's comment, the study does not evaluate specific tissue SAR, but neither do pharmaceutical toxicology studies, and we all take medicines every day that are never measured to specifically what exposure your brain or your liver or your kidney have. We look at whole body exposure through plasma or serum. That's a very worldwide industry standard. So we often do not know in an animal study or in a human study. It's definitely not in a human study. Not too many people want to volunteer a piece of their tissue to find out what the drug concentration is there. So we don't know that in chemical toxicity or in this case now in RFR evaluation as well. It's just
I appreciate
the context of worldwide standards.
Yeah, I appreciate that. That's a case, of course, that's what the pharmacokinetics does in terms of assessing various biological responses is concerned. I fully appreciate that. The point I'm making is that even though I have some reservations regarding how the exposure was characterized, how it was interpreted, so forth, I'm willing to take the word saying that, just like Dr. Kuster had just said again, it's a whole body exposure. In his interpretation, every organ is exposed to the same. This is what he just said. So that's why I'm taking in terms of SAR. Unless I heard it wrong, I think that's what he's just said.
No.
No?
I don't agree.
No, I mean, Niels, could you repeat
Maybe I can repeat it. I said, all tissues are exposed to different but similar levels. And so we know the variations. So for the wet tissues, variation is within 3 dB. So that's considered to be very, very similar. So for the dry tissue like bone or fat, it is lower, but that's not something we can anything do about. No. But this applies for the SAR. For the E field, it's much more homogeneous.
So could I just ask a question about the physics of how does surrounding tissue, so I'm thinking about the heart, so how does the lung, the rib cage that surrounds the heart, does that influence how the radiation gets to that tissue or concentrates it? Is there any understanding of the physics of that?
I'd answer that and say yes, that does make a difference. And those are calculations, and some of which we saw, show that you had a distribution in fields there. And Niels is correct. The distributions they saw were within a factor of 2. Okay, but they do vary. And yes, it does make a difference whether you have fat followed by tissue or skin, dry skin or wet skin on top of it in terms of what, and it's also frequency dependent on what penetrates and what does not. So there are variations there.
So I would agree with the comment that Dr. Lin said that this is a similarity would be where we do pharmacokinetic, pharmacodynamic modeling, but the fact is these are whole animal exposures with whole doses that are used, and the outcomes are measured histopathologically as outcomes. Dr. Adler, did you want to add?
Well, just since we're on the topic of the physics of distribution of RFR, the heart, so I had 3 days to sit and think about this in addition to the pre-reading I did before. The heart uniquely sits in an air cavity, and none of the other organs in the body do. So is it sitting in its own reverberation chamber, essentially, surrounded by thorax and air? And I don't know the answer, or that it belongs in the report, but it makes the heart unique anatomically with regard to most of the other tissues which are bathed in body fluid, as the heart is within its pericardial sac. But the heart is uniquely sitting in an airbag where no other organs in the body are.
So
I think actually this is a very complicated issue, and different people has different approaches to it. And as I said, if we want to look at this and emphasize the whole body exposure part of it, a bottle or red body doesn't really make any difference. That's one way to look at it. Another to look at it is what's been said, it does make a difference. So I think here's a dichotomy. Similar, when you use similar words, those are, what does a similar mean?
Dr. Booker.
So this obviously is an important topic, and it's a hugely important area that we be able to get this information in the report as accurately as possible. Our goal is to describe what we did as clearly as possible, and the utilization of that information and the comparison with human exposure limits and things is in the realm of the physicists and folks who evaluate this information in the regulatory agencies. So I would, to the extent that it influences your evaluation of this study, I think it's worth having a continued conversation on this. But to the extent that you can evaluate this study in and of itself and hope that we can articulate as clearly as possible what these exposures really mean with respect to the individual animal, whole body, and individual organs. Let us try to do that. I will say that one of the things that we have considered and will probably do is to place actual hyperlinks in the final report to the videocasts of the presentations that were made on the first day by Dr. Capstick, so that there is a way of, at least for those most interested folks, to go and find as much information as possible. But we will also have an obligation, and we do have an obligation, to try to get this clear in these reports, and we will do that.
Thank you for that. So, Nels, one last comment, and then I want to hear from the staff in response to Dr. Felders.
Exactly. Just to respond that the heart could be considered as a reverberation chamber, and it has not been correctly considered. That's a wrong statement. So we made a dosimetry of the heart. It doesn't go into detail that we can distinguish the nerve sheets, have values for the nerve sheets, but what we deliver is a very good proxy of the heart exposure. So very locally it might vary. We don't have that information. That information could be collected for any future studies, right? But what we have is a very good proxy of the exposure for the different.
Okay, NTP staff, respond to Dr. Felter's comments.
All right. Well, thank you very much, Dr. Felter, for your expansive comments. It was a very thorough review. First, I kind of want to address some of the conversation that we've just heard. I think one of the difficult things in this case with RFR versus chemicals is the way that the regulation is set up. With a chemical, you just exposed to a certain concentration either in the air or in the food. This is very specific to localized exposures, and I think that's going to be difficult for the risk assessment community to take and interpret what these studies and take that into apply that to a more localized exposure. But that being said, these studies were the target of the goal of these studies was hazard identification, and as such, we wanted to expose each of the organs to as much of the radio frequency radiation as possible. And I think from what Niels is saying, what some of this discussion was, just to kind of summarize that, is that we did the best that we could to expose each of the organs to the same level of RFR. However, there's only so much that we can control based on the dielectric properties and the absorption of those tissues. So as I think was shown on the first day, and as was just mentioned, I think we fell within a twofold range of that. And a part of that was coming up with the pairings of the 900 megahertz for the rat and the 1900 megahertz for the mice to make sure that we had as uniform exposures as we could. So, as you had mentioned a comment about a lay summary, and I think Mary had mentioned yesterday that we will have a lay summary when this report is finalized. I'm not sure that lay summary necessarily will address your comments about some of the dosimetry, use of watts per kilograms and SAR. You mentioned SAR sensitivity. There was a mention yesterday about inclusion of a glossary of terms. I think this is something that we'll take into consideration, and this might help clarify some of that, help explain some of these definitions, will help kind of bring some EMF knowledge to people who are more biologists. So I think that will be helpful. And as Dr. Bucher said, I think this whole question of SAR sensitivity, this is something that could be addressed with those presentations. I think there was also a comment yesterday as far as that I think a number of people had mentioned that when they came here that these presentations made things a lot clearer than they were in the report. And I think we heard that yesterday, and we've heard that again today. And I think, as Dr. Bucher said, we'll make our best effort to incorporate everything that was in those presentations into the report as best we can to make sure that that's as clear as possible. I think that this is a very complicated subject, and trying to make that as clear as possible is our goal. So. So you talked about the pup mortality and decrease in the statistically significant decrease in pup body weight that persisted up to the 14-week interim evaluation. Again, as I mentioned before, we didn't believe that the MTD was exceeded here. This decreased pup survival was observed at 6 watts per kilogram in the CDMA, but not in the GSM. Body weight changes were transient, 6 to 9% lower than controls, and so we couldn't determine whether or not this was an effect of the dam on pregnancy or direct in utero effect on the pups, on the pup growth.
Yeah, I think my comment there is to just be explicit in discussion on that point in the report.
Right, and we can clarify that to make that more clear in the report as well. Let's see. You mentioned that survival was lowest in the highest dose of CDMA male rats up through the 92 weeks. So we saw that there was that, I think as I showed on that graph, that it seems like that one group dipped below, and then by the end of the study, it was there was increased survival. And so we'll add that description in to the report to make sure that we identify that did occur over those course of those weeks. One of the other issues that you raised was the similarity between the modulations, what we saw with CDMA and GSM. I think we're very clear when it comes to looking at the heart that we saw these lesions in both GSM and CDMA. I think we kind of need to be careful when we talk about the equivocal lesions because we're not sure whether or not these are related to treatment or they're not related to treatment. And I think I understand your point that If you see a number of these things, all in the same lesions, and you're seeing it for both GSM and CDMA, that may indicate, and we actually did take that into consideration when we were looking at our calls to see if this occurred in just one of the modulations or both of the modulations. We also kind of looked between the rats and mice to see if there was any similarities. We'll say that each of the calls was made individually on either the GSM or CDMA, but the information, we used all of the information to kind of glean what may be occurring as far as similarities between those. There's been a lot of talk and a lot of comments in both the public comments and the reviewer comments about combining GSM and CDMA. I've talked to Dr. Shockley about this quite a bit, and from a statistical standpoint, it becomes quite a bit of a nightmare. And there's reasons not to do this. But I do think that there are ways, and we're going to be looking into ways of evaluating this and looking to see if there are ways that we can maybe combine this data and look at this. This really gets at the issue as to whether modulation is important or whether it's the frequency itself that's important. And so I think that this is an important point. So we do want to follow through with that and try to determine what ways that we can look at that to evaluate those differences or similarities. But we're not exactly sure right now how to do that. So I think, at least in my mind, and we'll talk about this as a group with the NTP after this meeting, is I think that this might be best addressed in follow-up manuscripts where we can really pull out very specific points and present some more of the data. We can focus on certain organs specifically instead of looking at whole differences where there may or may not be similarities. The time to tumor issue, we kind of talked about that yesterday, and it was kind of brought up again. I think we have to be careful when we talk about the time to tumor. That's not to say that we can't bring that information in. I think where that information will be helpful and useful in the lesions that we observed, we'll go ahead and add that into the report where it seems like it would bolster some of the argument. Another comment that you made that we've heard from several other of the committee members, as well as some of the public comments, is the references that we include, and to make sure that we include some of the more recent references. You also mentioned to be a little more specific in the introduction about the types of exposures or the conditions under which these observations were observed. So we could go ahead and go into the introduction and make sure that we add that information, so that will be a little more clear, so you get a better understanding of where this fits into other studies that have been done. I think that concludes, unless you have something else, that concludes your comments. Again, thank you very much for a very thorough review.
Oh, thank you. Unless there are any other comments on this, we will move to Dr. Klein.
Thanks. So yeah, Mark Klein, Professor of Pathology and Radiation Oncology at Wake Forest School of Medicine. I have cut down my comments a bit, but unfortunately I've still got quite a few, so I'll try and be as succinct as possible. I think greater clarity regarding the RFR chambers is needed. For me, around the control chambers especially, and how they were confirmed to be zero or near zero exposure. I sort of informally learned that in discussion, but it'd be nice to state explicitly that they were shielded, there was no antenna in that chamber, and so on. I would like to suggest making some assessment of the sympathetic and HPA axis with respect to stress assessments in these animals. The adrenal gland weights are not in the body of the report. I think it'd be nice to move them up into that and to discuss a bit the likelihood that the pheochromocytomas might have resulted from some chronic stress response. Let's see. And there are multiple indicators of stress-like responses in the report. So, for example, the lower gestational weight, weight loss during lactation, lower pup weights. I mentioned the numbers of PHEOs. And I would myself put in the cardiomyopathy as well. It would be interesting to line up some of these potential stress effects to see if they correspond in the same animals. So, for example, are the animals with pheochromocytomas the animals with cardiomyopathy? Are the animals with pituitary tumors the animals with elevated adrenal weights? I believe if there was gastric ulceration or some other overt indicator of stress, that would have been picked up, so I think that's probably not there. But if there is additional information on that aspect of the study, it's worth mentioning. Mammary gland assessments, I would like to see some discussion of that. You know, the pituitary tumors in rats are usually lactotroph tumors. If that was the case, there should be some secretory activity in those animals. If not, I would wonder if they were corticotroph tumors, which would be different from what's usually seen, and some immunohistochemistry might illuminate that. Let's see. I would like to request some clarification regarding the nature of the noise within the testing apparatus and how audible it was to the rats. We discussed that on day one, and didn't quite get that resolved as to whether it was in the rat vocalization range. I think that could potentially be important and could potentially be a source of distress if it's in that ultrasound vocalization range of rats. I would second the comment that Dr. Whiteley made regarding histologic exam of the female reproductive system, and I would specifically ask that the 14-week assessment be looked at a bit harder. The end of the study assessments are probably confounded by senescence, but I'd like to ask that be considered. The GSM 2-year study, the greater mortality in the male rats, is really interesting. It's attributed to chronic progressive nephropathy, and I think that's reasonable. But then there's another statement made on page 156 that the lower chronic progressive nephropathy is due to decreased food intake, or may be due to decreased food intake. That's not really supported by the body weight data. So I think there's a need for more mechanistic discussion of why the chronic progressive nephropathy was lower in the RFR treated groups. The next topic, auditory and vestibular tissues were not examined histologically. I don't view this as a fatal flaw given the extensive brain exams, but I would recommend that the auditory and vestibular tissues be trimmed in and examined histologically. Let's see, minor point clarification of whether the historical controls include the controls from this study. That was raised yesterday. I just want to make sure that there is a distinction between the controls that are called concurrent and called historical. I don't think they can be both at the same time. That's it for me.
Questions from the committee to Dr. Klein? Okay, response from NTP staff?
Thank you, Dr. Klein, for your comments. A lot of your comments focus around the stress, and you know, some of in your written comments you asked about some of the testing, or if we had measured certain things, and in hindsight we haven't done that. But as we do look forward into future studies, these are things that we'll definitely going to keep in mind as we design those studies. You mentioned the adrenal weights. You would like to see those brought into the back from the appendices into the text. We could consider doing that and providing more of a discussion around the pheochromocytomas, tying all of that together. We could do the best that we can to kind of relook at that and see if we can increase that discussion to kind of clarify that, kind of bring that issue out a little bit more. As far as the noise is concerned, we talked about that on day one with Miles. I do believe, and somebody could correct me if I'm wrong, that is within the range of rat vocalization. Is that correct? But again, I think what was discussed on the first day is that we did account for all of the noise in the chambers by piping the same sound from those high-dose chambers into the low-dose chambers. So everything was normalized across the study. As far as addressing the issue of whether or not that was stressful to the animals, I'm not sure that we would be able to. I think that would be speculation at this point, but we could make sure that we include as much of that information in the report as possible. Let's see, you had mentioned about if we had looked into whether some of these lesions were occurring, if there was one lesion in an animal. Did you see the same, did you see the cardiomyopathy in the same animal that you saw the glial cell tumor, or looking at those combinations? We have not looked specifically at looking at the association of these lesions, if there's all of them occur in one animal or certain animals, but that is definitely something that we could go back and take a look at to see if there is something that pops up. One of the things that you mentioned too is about the control chambers, that I guess the description as far as that these were shielded with no antennas to kind of demonstrate how they were similar or different from the exposure chambers. We could make sure that we increased the description in the report. And I think we heard over the last 2 days that there was some confusion, it seems like, as to whether or not the animals were only exposed to GSM or only exposed to CDMA as far as this 10-minute on cycling. So this is all part of what we'll clarify in the report to make sure that that's as clear as possible. As far as the comment we made with food consumption, that was a bit of an overstep because we don't have any food consumption, and to relate that to CPN, it hasn't really been talked about why we don't have food consumption, but the main reason, obviously water consumption, we couldn't measure because it was on an automatic watering system, so it was difficult to measure, but food consumption, food was actually placed in ramekins at the bottom of the bowl, in a bowl at the bottom of the cage. When the animals were very young, during the perinatal exposure, some food was scattered on the floor to make sure that those animals, the younger animals, could eat that. The rats could scatter food across the floor, so it was very difficult to be able to measure food consumption. It was nearly impossible to be able to determine exactly how much the animals ate. So this was a logistical issue as far as not being able to measure food consumption in these studies. As far as the auditory vestibular tissues, this was, again, as you mentioned, something that we did not look at, but we could cut in those tissues and take a look at those areas, I believe. And Dr. Sesta could correct me if I'm wrong, but that is an assessment I believe that we could go back and do to take a look at. I think there was some discussion around what was seen in the head through the other evaluations, but again, this is something that we might be able to specifically go in and take a look at. And lastly, before I turn it over to Dr. Sesta, the historical control, I think we've heard is a little confusing, especially for the rat study, because there's such a small number of studies that there was a disproportionate emphasis on the concurrent controls as evaluated through the historical controls. And just as was mentioned yesterday, we'll make sure that we clarify to identify that those studies and the incidences in those studies specifically can be understood. I think yesterday we talked about it for the mouse to in the appendix to put each of the individual studies in there in that case, so you could look at the incidence in each of the individual studies. So this is something that we'll clarify a little bit more, because I think that's a valid point, because the 90 animals in this study do skew the overall historical control rate when you're trying to compare in this case.
Before we move on to Dr. Sesta, does anybody have any questions on Dr. White's comments? I have one, which was just a clarification on the issue of noise. That you said that you basically piped in the high dose noise to the other chambers. Does that include the controls?
Yes, I believe that includes the controls.
It did include the controls. Okay.
Yeah, so we can make sure that that was across all of those, but that was again that was the noise that was from the high dose, and I believe Miles showed the MP3 player, and that was
the point being, if there was a stress-inducing aspect of that noise, the control animals saw that as well.
exactly, and that's what I mean. That all of the animals were handled the same way.
Thank you.
Could I ask a technical question? How did you do the piping in this case?
Dr. Kapsik?
Is that on? Yeah. What we did, we put a pair of loudspeakers in the air outlet plenum and fed it through the ventilation tubes into the chamber. The chamber's got very reflective surfaces, so it then bounced around the chamber and was approximately the same level throughout the chamber.
Thank you.
Dr. Adler, yes.
Rick Adler. So question follow-up to Dr. Klein's question about the incidence of chronic progressive nephropathy, and following on offline discussion I had with Dr. Rinke. Water bottles were validated for thermal effect, but could you remind us what the evaluation was for feed exposed to RFR, and whether there was evaluation of thermal degradation or micronutrient effects on the food?
Dr. Kapstick?
Yeah, Miles Capstick. We measured the amount of power absorbed by the food when all the bowls throughout all the cages were fully were full, and they were absorbing relatively small amount of power. It was measured in a few watts. So when that's distributed over the whole volume, and it's got relatively large surface area, we don't expect any particular increase in temperature in the food.
So just to be sure, though, there was no follow-up micronutrient evaluation of the feed itself?
No, we didn't look at the feed after irradiation to determine whether or not there was any kind of effect on the composition of the diet or changes to any other components.
The reason I follow up on this is because we know rats that ad lib feed have a higher incidence of chronic progressive nephropathy, and when they're calorie restricted, they have a lower incidence and they survive longer. So I don't know what bearing this has on the RFR exposure to the food, but it's something that perhaps the NTP should think about and follow up on, and even be transparent about in the report.
Dr. Puka.
So a point related to that is the fact that these are autoclave diets, so they're nutrient enriched to take the autoclaving into consideration, so that the degradation of nutrients during that autoclaving process is taken into consideration. So it's unlikely to me that the heating from radiofrequency radiation is anywhere near that the temperature or for the autoclave. So I suspect that that's a minor contribution to a nutrient degradation.
And that's the temperature side, and then also on the other side is the energy side, because this is non-ionizing radiation. There's not enough energy to strip off any of the electrons, so through that mechanism you wouldn't expect it.
And so I only ask that the report just be transparent about all of that, so that if there's someone who wants to criticize the report as a weakness, then there's a defense of it included.
Angela King Herbert, laboratory animal veterinarian. So actually our food is irradiated, and we check for the nutrients prior to irradiation and after irradiation. Our food is the NTP 2000 diet that the animals received is a low protein diet, unlike the diets that are typically used in for rodent studies. So the protein levels in these diets are up to 15%. So, yeah.
So thank you for correcting me, Angela.
Well, to clarify, though, what do you mean by radiation treatment? X-ray, ionizing radiation treatment, or RF treatment?
So it's irradiated, meaning gamma irradiated to produce a sterilized, mostly sterilized diet. Angela King Herbert again.
Okay, Dr. Sesta.
Mark Sesta. So I just wanted to add to what Dr. Wyde said about the vestibular system and the eighth cranial nerve. There was a thorough gross review of those tissues. So, and we didn't identify any lesions, but as he said, we can try to look histologically. And as for the pituitary tumors, we did not look at individual animals to try to see, if the animals that had pituitary tumors also had mammary gland tumors, but that's certainly something we can go back and do. And if necessary, we can do some immunohistochemistry to try to identify what types of pituitary tumors they have.
Is it possible that you could do hormone analysis, especially steroid and pituitary gland hormone analysis on serum that you have from like the 28-day study or anything like that in terms of getting at, I don't know, Dr. Klein, if that would address your concerns about stress-induced changes between controls and exposed animals?
I just sort of assumed that serum was no longer available, but serum cortisol would be interesting, and the pituitary gland immunohistochemistry should be pretty straightforward if you wanted to go that route with the fixed tissue for ACTH and prolactin.
I would say that we don't have any of that serum left.
Okay.
Maybe just one comment. I notified that you have investigated the Zimbel glands, and I guess it was done in the conventional way that you had it very close to the auditory cavity, and so if there would have been something, I guess it would support that it was not seen anything.
That's a very good point. Thank you.
Just to, if I may just follow up briefly on that, was that a decalcified section of the back of the skull for the Zimbel's gland exam? It was. Okay, so the section of interest may have been examined. If so, please just say so in the report.
We'll look into it.
Thank you.
Regarding the comment on the examination of tissues around the auditory cavity, of course the auditory nerve doesn't go through the cavity, so I wondered again what would the answer be regarding that, as far as how far did you examine grossly the tissue surrounding the auditory nerve?
So the routine would be the calvarium is removed and the brain is removed, and we do sectioning through the nose, 3 sections through the nose as a routine, and that third section through near the base of the cranium would potentially hit the vestibular system. But we would look at that all grossly too, so we would, if there's any gross masses, then we would detect them at that point. And then we have those sections in that area of. Just a comment on the about potentially hitting the vestibular system. So do you know that, how frequently do you hit the vestibular system, the inner ear, to be able to evaluate those structures? I mean, there's clear anatomic landmarks that you can specifically cut. Somebody has done that work. We've done that work. See, how often do we find that in the section? I don't know, Robert, do you want to?
So this is Robert Sills. We'll go back and look at it very carefully and make sure that we add to the report or do any additional studies. I think the comments made were very helpful. So we'll do that. Thank you.
Harkema.
I've looked at a few noses, and I doubt if you would you would have gone through that at that third section. You may, but it would be pretty much hit and miss, I think.
So we didn't routinely look at that area.
Yes, Dr. Sesta.
I would like to add one more thing. During the APS, we would go back and review the brains grossly, and so that would be after they were sectioned. So we would see the cut surfaces as well. So that would add more to the review than the original review.
Oops, sorry. Any further comments? Okay, we will move on to Dr. Malice.
Tyler Malice. So yesterday we went over a variety of rare tumor findings. I believe most of the rare tumors were talked about occurring in your mid-dose RFR groups. And then today, when we went over multiple equivocal findings, I also observed that there were sometimes elevated tumor occurrences in your mid-dose range. Yesterday we discussed the possibility of a non-linear dose-dependent trend, and one of the thoughts that had occurred to me is it wouldn't be too labor-intensive to aggregate tumor occurrence information for a particular group of mice across your dose range. So I'm not very familiar with all the tumors, so I wouldn't want to combine them in any way analytically, but I would be very interested to see a table for a particular type of mice or rats that has, for a particular type of rats, that have dose, and then a list of rows with different columns, attempting to get at the question of, hey, is there supporting evidence for a nonlinear dose-dependent response? I'm not saying that could tell you, I'm just saying it could be a way to explore that with data you have, so no biological samples needed, just with your data. In line with that, I was a bit impressed and shocked to see how different your slides were for different grades of tumors. When I originally looked at the severity grading for your tumors, I thought, oh, well, a 1.2 is probably quite similar to a 2. And then seeing that, I think the highest slide you showed today was a 3.7. And I looked at that and I said, that looks very severe, whereas some of your lower graded slides look, from a layman's perspective, I wouldn't have said there was anything wrong there. And one of the things that I can say on the analytics side is you may wish to consider including some of that grading information. I don't know exactly what would be appropriate, but to me, some of your high-grade tumors, I would think you have an argument to say that's much more severe than just a 3 versus a 4. Just something you could look into. Otherwise, I think I'll reiterate my point and the point that many people made yesterday, the importance of a well-flushed out system of controls, as we face that repeatedly. Then obviously the emphasis on reproducibility of your results. One thing that I think you're going to face as the findings of this study are discussed is obviously the relation of your 2G and 3G technologies to the upcoming 5G, and also how your dosing protocol relates to, say, the dosing that I might receive on a daily basis as a casual cell phone user, or the dosing that an individual, say, in a call center might receive. And I know that's getting a little bit outside the basis of the study, but I think as it's discussed, these are some very common things that most people are going to want to talk about.
Questions from the panel? Yes.
It's not a specific question, but also kind of on the point that was just made about perhaps looking at the data a little differently for, and I'm not a statistician, but I think that's an excellent idea. But I also wanted to point out that you know, following on to what Dr. Felter said, not just the combination of like the GSM and the CDMA, but looking at systems as a whole. And Dr. Klein also mentioned the HPA axis. And when you look at a lot of these tumors that were considered to be equivocal, they are all, or the majority of them, are in the endocrine system or neuroendocrine system. And so is there perhaps some consideration of looking at, you know, because I think as I'm used to working with exposures that are with a compound that is specific to a specific receptor, and you know where that receptor is. And so, you know, we brought up the concept of the biological plausibility several times here. But when we're talking about something like this RFR, where there's not a specific receptor within the tissues, but now we've got a set of data, and it may be equivocal, but why is it all, a lot of it in the endocrine system? And so perhaps maybe looking at the endocrine system, or at least making some kind of comment on that in how you're looking at the interpretation of the data. Is there something that, does that increase the level of suspicion that so many of these things are kind of pointing at that one system, and not just from a stress point of view?
Thank you.
I would like to ask a question to Dr. Malis. When you have, I'm not a statistician at all, but when you have a study where I believe this is true, that you have 6 times more exposed than controls, is that about right? Something like that? I would just, what implications does that have?
I'm not sure I can answer your question in a meaningful way offhand. Sorry.
Well,
Dr. Adler.
Sorry, Rick Adler. I said yesterday I hate statistics, but I love statisticians. And I appreciate, Dr. Malice, that you went away yesterday and thought about the question of nonlinearity and came back with some suggestions. Jack, I don't know the answer either, because again, when you put a mathematical signals, I just completely turn off. My brain just goes dead. But when you have 6 times more animals given a treatment than the controls, you have some numerical increase in the number of opportunities for a random event unrelated to the treatment to actually occur in one of those groups. And in the pharmaceutical industry, it unfortunately too often happens in group 4, the high-dose group, and we're stuck trying to explain that outlier. So, you know, I can't explain that mathematically, but I'm sure statisticians going away and thinking about it could probably come up with the exact answer.
Okay.
So
yeah.
I would ask, is he right?
So I'm going to say yes. That would be the, if you want an excessively simplified answer. Yeah. So one of the issues that we've faced, and many people have commented on it throughout this study, is the limited control. And one of the points that I keyed in on, which was presented earlier today, was the lower survivability in the control. And one of the reasons I would advocate for future studies to have much more robust control systems is that that's a very important item to discuss in terms of reproducibility of the study, right? If I look at that result and I say their control mice are not surviving as long as their treated mice, I have a hard time interpreting any result as being positive. I can say, yes, there's findings here that need to be looked further into, but when you have a small control group, the odds of having a random event are higher, and that was very well put.
NTP staff, other response?
Okay, Keith Shockley. Thank you for your comments. Especially, I think you've talked about the potential non-linear response that we see in the data. And so I think it's a very good point that we could start to maybe, we could look at summarizing the results and see what that might tell us. We use a linear-based trend test in the tumor analysis. So that kind of a test would have much lower power to detect the non-linear type trends. But we do use the pairwise test as well, which can help us out in that regard. I think the controls have already been talked about, and reproducibility to some extent. So again, I guess along those lines, transparency is important for us in terms of reproducibility. And then, we use a weight of evidence approach, which we've talked about before, and not just statistics. And so all of that historically has shown that that we're getting good results in NTP. Let's see. There were some other issues. I think that was maybe about it. The issue of. Did you want to?
Yeah. So just to be clear, when I talk about aggregating tumor information from different tumor types, I'm not talking about combining that information to perform a statistical test. I'm talking solely about the concept of exploring that data to see if there's any possibility of that a trend may exist. So it's a subtle analytical distinction, but it's important because combining results can be incredibly statistically difficult to accomplish. Whereas just taking a look at your data and exploring it in creative ways, the whole data science trend we see today, can also yield meaningful insights into your data. I want to make sure that distinction was clear.
Sure, absolutely. Thanks. So thank you.
Dr. Barnes, did you have a quick comment?
Yes, I have a comment. I know of at least 4 studies and maybe more where you wind up with health effects as a result of exposure. In other words, increased rate of recovery from a heavy dose of x-rays in one case I know about. Other cases of animal studies where you wound up light exposures leading to smaller incidents of problems, etc. So I know of at least 4 studies along that line. And so the fact that increased lifetime as a result of exposure is a possible real outcome that ought to be considered.
Yeah, this is a very well-known phenomenon in terms of diet and weight gain over life, that calorically restricted animals live much longer. Yeah. Dr. Lin.
Yeah, regarding combining the incidences and the indication that this is incredibly difficult, that might be incredibly difficult to handle, I would like to ask a simple question. I'm not a statistician, so in this particular case, the focus of the exposure anyways on the whole body exposure. Now, granted, saying that, well, if you say that the deposited dose is within a factor of 2, so let's take that as a similar kind of a context. So within the range of 2, given that the animal is exposed to, I use the word similar also in this case, that similar doses, and the design was not to target any particular organ or tissue site. Then subsequently you observe neoplasm or hyperplasia in different tissues. What would be the difficulty in taking each one of those occurrences and just say, having been exposed to, say, CDMA, and defining data has been acquired, and of course we have better or worse, a set of control data that we can compare against. What prevents you to do that? What would be the difficulty in simply comparing those two set of numbers? I mean, again, the study has revealed a number of different tumors in different tissue sites. But regardless whether it's adenoma or carcinoma or glioma or schwannoma, they are all tumors. So is there any rationale to suggest that we just cannot combine them all together and say, given the exposure, this is what was revealed compared to no exposure?
Dr. Shockley.
So it sounds like you're asking combining all the tumors across all doses as an analysis of total tumor burden, and so that's actually done in the analysis, and it's presented at the end of the P08 file. So we actually have done that. We don't use that information here to make our decisions, but we have that analysis available.
I guess the following question would be why that data cannot be used for evaluation.
Well, the answer is it can be used, and it has been used in years past. But typically, the total tumor burdens are comprised of common tumors and the vast majority of the total tumor burden is spontaneous tumors, and that if you just pay attention to that, you can miss this more subtle things like the schwannomas that we would have pointed out. So traditionally, originally when cancer bioassays were originally begun, there was an emphasis on looking at total tumors, and I think that through the years it's just been something that's been set aside as being less useful. But there's no reason why it can't be looked at.
I'm not suggesting that that's the only one that's going to be used, but rather including that in addition to each of the animal species and each of the modulations, an analysis that includes the total number of observed tumors in the exposed versus non-exposed.
As Keith said, we have that information and it can be added.
It's just a matter of adding some discussion of that into the report then.
Good, okay, thank you.
Thank you. Okay, we will move, any more response from NTP staff to Dr. Malice? Okay, so Dr. Whiteley.
So Larry Whiteley, Pfizer. So just to, I haven't heard it today, but I heard a lot of it yesterday, is just to commend the NTP on conducting this study and the heroic efforts that went into the engineering, which I didn't appreciate until Monday. So I congratulate the organization for doing that. So just a couple comments, just to reiterate, I support a lot of what's been said. And the issue around bringing forward latency, you have it in the tables, which suggests that you think it has some value. I think there needs to be some written statement then about whether that adds any value in the assessment of carcinogenicity for a given tumor. And if you want to discount it, say why. And then the other, we've talked about this before, but I think it's incredibly important to distinguish the glial cell type, because if you just look at a lot of the comments, everybody's combining the schwannomas and the glial cells as myelin-producing cells, and if that's not the case, it may have a difference in interpretation. So just want to call that out to do that. And to echo Dr. Felder's comment about looking at the two different modalities, and I think it would be incredibly helpful if you put tables in for where you've identified target organ effects, where you put male and female CMS or GSM and GDMA in tables. They were in some of the slides, but I think it would be very helpful from an understanding and a discussion point if that was in the report, because it's very hard to go from dramatically different parts of the report and try to visualize commonality. So that would add to the clarity. I think the biggest comments I want to make are around the discussion. If you look at this study in combination with the recently published one from the Italian group, as well as what's in the literature around human response, you have a concordance of effects from multiple studies pointing in the same direction. I think that needs to be brought out in the report because it adds significance to the findings in this study. And I think there ought to be a significant discussion around that. The other key point of discussion, I think, is around nonlinearity and potential for biphasic effects. So you discount the significance of some of the single non-dose linearity findings as decreasing your confidence. But we heard from Dr. Barnes around biphasic effects. I don't know how much of that's in the literature, but I think there ought to be a discussion around if there is a biphasic effect, how does the potential for that to impact your interpretations of significance. It may be speculation at this point, but I think it would lay the groundwork for further investigation, and it ought to be part of the scientific discussion of the report. And then the last comment I had, it's minor, but when I first started reading this, I got through the abstract, and I was thinking, why did they pick the doses that they picked? I think there needs to be a clear statement in the abstract, a couple sentences of this is why we picked the high dose and this is why the mid and the low dose were picked. It doesn't need to be extensive, but at least give some perspective to the reader on why the doses were picked. And that's all I have.
Thank you. Questions from the committee to Dr. Whiteley for clarification? Okay, NTP staff respond. Dr. White.
Thank you, Dr. Whiteley, for your comments. We had some conversations earlier today and yesterday about the time to tumor, and I think we've kind of discussed that. As I said, we'll put that in where appropriate, so we can add that information in. The issue of glial cell type, I think we touched on this a little bit earlier. I think Dr. Sesta had mentioned that we have some tissues available to maybe do some further investigation, some immunohistochemical staining or some other methods to look at this, and that's stuff that we will evaluate and move forward with. Your comment about the two modalities, about the similarities, you had mentioned the tables that I had put together in my presentation. I think that's a good idea to have a summary. We could have those tables side by side where you look at GSM males, GSM females, CDMA males, CDMA females, and that way you can kind of look at in a quick summary and identify maybe the similarities, which would kind of add to some of the discussion that people have brought forward, that they want to see more discussion about these similarities between the two different modulations. So that's something that I personally think would be agree with you. That would be a great addition to be able to look at that as an overview. Again, you'd mentioned about the bringing in the information from the human studies that these are similar cell types or similar tumor types. The vestibular schwannomas are similar to the schwannomas that we're observing, and so that is something that we can add into. I think one of the reviewers made the comment that we actually did make a statement about that in the partial findings report, that didn't actually appear in the 2-year study, and we can make sure that we address that in this report as well. We've talked a lot about the issue of nonlinearity, so I won't beat that horse anymore, but we will take this all into consideration. One of the things I would like to point out is that it's not necessarily in all the cases that we necessarily saw an increase at the one of the lower exposures, but it was also in a lot of the cases that just the incidence of that response was very low, and when you look at that compared to historical controls, so it wasn't statistically significant. So I think we have to take this on a case-by-case basis to determine which ones may, in fact, if there's nonlinearity is an issue, which ones may kind of fit into that category versus not, based on the response that we saw. And again, I think you had mentioned yesterday too about the exposure selection, and we can definitely, there's a lot of information kind of separated out in a lot of places, and I know you mentioned about the abstract. We can make sure that in those places where we discussed that, it's a little more clear, not just how we selected the high dose, but how we distributed the exposure levels below that, and we'll make sure that a more complete summary appears in the abstract. So that's the first time that you actually see that. That way it'll make more sense as you go through the document.
Any response or comments from anyone else? Yes, Susan.
So thanks for being willing to consider putting together these tables that look across, like for one particular organ, looking across the modalities and sexes. I think it would also be helpful to include any hyperplastic responses along with tumor responses in that summary.
Just a further comment on that. I could envision some clustered bar graphs where you have CDMA, male, female, GSM, male, female for any given tumor type across the 4 doses. Then you can visually see that for taking the major tumor types. There you see where there is concordance and where there is not. Okay, any other comments? Thank you, Dr. Whiteley. We will continue on our journey here with Dr. Adler.
Thanks very much, Rick Adler. Sorry to be between us and lunch. I don't know if there's one more panelist
So
after me.
let me comment on that. We'll go through here. I really would like to get through this session, even though we will extend. We just have to be in the cafeteria before 1:30, right? But we'll get there. We should be there by noon, or by 1 o'clock is my hope. And then we will take a shortened lunch break. So let's continue.
Okay, well, I'll try to minimize my editorialization. So I'd like to also echo things that have been said between yesterday and today about the NTP. And for me personally, this is an honor and a privilege and a very serious public health responsibility that I don't take lightly. So I don't recuse myself from this panel. I've spent nearly 3 decades in an industrial career as a veterinary pathologist, questioning the thinking of other people and being challenged in my own thinking. And I purposefully use provocative questioning to help people bring what's in their head onto paper. And so if I do that in my next few comments, it's because that's my style of getting people to be more transparent. The NTP is something very unique on the planet from my point of view. It is the most transparent and has a very high degree of integrity of any agency I know of. And in this day and age, it's remarkable that it demonstrates that commitment to transparency and integrity, and I'm greatly appreciative of that. These studies were well designed, very well conducted, robustly analyzed, and obviously robustly reviewed. And I do think they stand up to a great deal of scrutiny, and I appreciate that the NTP has allowed us all in to the doors to question their modes and thinking and modalities. This is quite a commendation to all of you. The report doesn't make clear what a lot of us know in the industry. It is solely a hazard identification study. It is not a risk assessment study, and that's a separate step. What I think I heard in the last 2.5 days is that the FDA is responsible for the risk assessment. I don't know if that's true, but if that is true, then I would like the report to say that, so that when lay people read this and when other stakeholders read it, they don't confuse the 2 steps that are critically important. Hazard identification is what happens to the animals. and the characterization of that. And then risk assessment is what's the relevance of that to humans, and that's a separate step. And I hope that that step also has the same degree of robustness, transparency, and integrity that what I witnessed for this step of the process. Dose rationale has been mentioned. I mean, that's my term, dose rationale. The dose justification is clearly needs to be added to the report. Things such as, why the 10-minute on and off cycle, the reason the frequencies were chosen, the rationale that the top dose was determined by maximum tolerated dose on thermal basis. That wasn't clear to me until I came here and listened and learned over the last couple of days, and so I'd like the report to bring that out. The separation of doses, Dr. Capstick, you went through that on an elaborate level, math that went over my head. But I do think that needs to be in the report, because that's the reason we do toxicokinetics in a chemical toxicity study, is to show that the doses are indeed different. It's not just this one got 5 milligrams and that one got 20 milligrams, that the exposures of the animals are indeed different. Now, this is a calculated exposure, but I do think that the rationale behind the separation of doses needs to be in both the mouse and the rat study. And so beyond a hot link to his report, I'd like to see some verbiage added to the reports as well. Historical controls have been discussed quite a bit in the last couple of days. I think that there needs to be some discussion within the reports about the credence of using historical control for this kind of study, because this study clearly is, these two studies are clearly unique in their methods. Not to say that the historical controls should be completely discounted, because they do add a lot of context and sometimes confidence and comfort around the conclusions, but they've been also criticized, and I think the report would be fair to bring those criticisms to the surface, such as the decreased survival of the rat controls, the increased incidence of CPN, whether that's relative or not to their validity compared to the limited number of Sprague-Dawley controls that the NTP has control groups compared to. Fluorescent lighting versus incandescent lighting. Dr. Lin, you brought this up, and I'm not a phototoxicity expert, but the concern that I know about fluorescent lighting is around retinal degeneration and cataract induction, and no evidence of that occurring or not occurring in this study, and I don't know that incandescent light has ever been used in an animal room in my career, so it's unique in that way, but I seriously doubt that it's had a negative impact to disqualify the historical controls, and perhaps the report should reflect something about the light source more transparently than it does. Many of the findings are determined to be equivocal by NTP standards, and that word catches my attention. It clearly is an NTP standard of definition. In my company, we use uncertain relationship to treatment instead of equivocal. And when our reports go to a regulatory agency like the FDA and others worldwide, and they read, we declared something as an uncertain relationship to treatment, they err on the side of patients and human health. And they consider when we call something uncertain relationship to treatment that it's actually probably positive from a conservative risk assessment. So I hope when these reports go forward with many of these findings called equivocal, that they're regarded the same way by the agency that does the risk assessment, that they err on the side of public health. It was mentioned by Dr. Corcoran yesterday, and I just want to repeat it. He suggested that some sort of a decision rubric around weight of evidence be used in the mouse study, and whether that can or can't be done, NTP can go away and debate that. But it is, when I listened to you today, Dr. Wyde, you spoke specifically about the rationale for the distinction between why we call it equivocal or some evidence, and that sometimes can be a thin line. And I want to make sure that the criteria that are used are as objective as possible. So, how much weight do you put to historical control in that decision? Or how much weight do you put on the statistical significance? What's the weight of linearity expectation versus nonlinearity? A lot of the decisions are based around not SAR dependent. And yet, if this has a nonlinear response, then what is the weight that we should put to that particular criteria of decision? And thank you again, Dr. Malice, for going away and thinking about that question and bringing back a statistical suggestion. The MTD is based on thermal evaluations. It's clear now that it was not measured at night, so it's measured during the day when the workers were here and not at night when they weren't. But we know that rats and mice are metabolically much more active at night. I don't know the diurnal variation in their body temperatures, but I suspect that when you eat and you digest food, your body temperature does go up slightly. And so I think that there probably is some future study that should look more in detail around the thermal effects. It can't be done, obviously, now in this study, but the thermal effects and physiologic effects of RFR deserve some future exploration, because I think there's potential for understanding more about the mechanisms, but also about the biomarkers that need to be understood. We as a society cannot wait for human lifetime to tell us that cell phones do or do not cause brain tumors. And even waiting for 2-year animal toxicity studies is a long time, because they take another year to evaluate and even longer. So we have to find biomarkers, and I strongly encourage the NTP to aggressively pursue the idea of what are the parameters that can be evaluated between the time you expose an animal to RFR and when it actually would develop a neoplasm at the end of a 2-year study, because these measures need to be applied as soon as we can possibly validate them. The studies are also chronic tox studies. They're not just carcinogenicity studies, and I do agree with Dr. Melnick's suggestion yesterday that they should clearly name what the target organs are, and I don't know if the reports do that, but the tabulation that includes GMS and CDMA side by side should also, in my view, include neoplastic and non-neoplastic findings and the additive aspects of those, because I do think that those point to more clearly to pictures of what the target organs are, whether they're equivocal or have some evidence of neoplasia. I do think that the brain is a target organ, the prostate is a target organ, and in the rat studies, the heart is a target organ. And this brings me to comments I made earlier about right ventricular cardiomyopathy. This is unusual. To have a high incidence of right ventricular cardiomyopathy. The literature supports that. Perhaps the NTP hasn't done enough Sprague-Dawley rat studies for 2 years to see it, but I think there is enough literature to show that what we have occurring in the study is unusual and it needs to be brought out. Dr. Sesta, you answered already that you didn't see an association spatially between the right ventricular cardiomyopathy and the occurrence of schwannomas and Schwann cell hyperplasias. And where you identified associations or you looked for them and didn't see them, I would like to see the report also identify those associations or the lack thereof, so that all the extra thinking that I know pathologists do when we are stimulated by what we see on a glass slide, and we go, let's explore that, additional idea, that should be in the report so that, it's as complete and transparent as possible. Similar example with the rat hippocampus being positive for the COMET assay and the CDMA, and I think you probably can already answer that there was no association to brain tumor, spatially, but that also is something that, should be answered. When we look at these types of studies, when I look at them, I look for signals, big, high-level signals that can infer mechanisms. And, I don't have the answers. I have more questions than answers. But the heart is clearly sending a signal in the rat studies between the level of cardiomyopathy and malignant tumors. And so I think this is a ripe area for future exploration to understand, what's going on there mechanistically and whether this can also yield biomarkers for, evaluating instead of the long latency period. I think that's my list of things that I've listened to and heard and want to respond to from the RAT report specifically, but also over the last couple of days. Again, thank you for the honor and privilege of being here.
Thank you, Dr. Adler, for your comments. Questions to Dr. Adler from the committee? NTP staff respond? Quickly, please.
I think the question of controls, obviously we all know that the three types of controls.
Could you speak a little closer to your mic?
Okay, sorry about that. Yeah, as far as the controls are concerned, as far as I know, there are three types of controls that typically gets involved. Cage control, sham control, and the exposure. That's just the two types of controls and then exposure. I think the purpose of the control is to provide an opportunity or an environment whereby, other than the specific agent being experimented with, every other aspect of the environment is as much as possible the same in two different settings. So, of course, in this case, there's no cage control. We are talking about sham versus exposure. So when the sham, in this case, used environmental controls as a different from what we call now historic controls, it presents a degree of difficulty to ensure that the animals were indeed exposed or subjected to the same environmental conditions. We do that for temperature, humidity. Of course, we do that for mechanical noise, as we have heard. In this case, the mechanical noise was equalized in the sense that a specific effort was made to transmit the sonic signal at the level where the 6 watts per kilogram chambers were experiencing. By transmitting this to the sham control, the assumption is that they are subjected to the same level of noise. Now, that's a good example, I think, to use. Instead of, say, using the noise that was recorded, or the mechanical noise that recorded in the 6 watts per kilogram chamber, let's say they chose to use white noise, which is totally different. It's kind of mechanical noise. It's sound. Or maybe we include some ultrasound in that also, depending on how it was generated. Certainly you could do that. And I think by all the indications that we have had is that there are some frequency component that the rats and mice are responsive to. 35 kilohertz or so for the rat, for example. Okay, so I assume that's the case because there were some indications to that. But instead of doing that, you provide a background white noise that's equal in every frequency component. Would you then consider that those are the same conditions? I would not. For the same reason, whether the chamber was illuminated with incandescent light or fluorescent light, given the fact that they are totally different, whether they have a specific biological responses to the animals that were exposed to them is a separate issue. Is that whether the conditions being established for those two settings are exactly the same. And I think the answer is clear that they were not the same. They are not the same because the historical controls, by and large, all of them were lighted using fluorescent light, as far as I know. That's part of the feedback.
So Dr. Lin, we've talked a lot about that, and I appreciate that difference. I think that what we need to do is people will just have to evaluate how much, and I think that the issue of how historical controls are weighted in this consideration compared to concurrent controls is very important. But we spent a lot of time talking about the differences, and I agree that there are clearly differences between historical controls and the controls and the conditions of this study. So if you'd like to sort of summarize to the bottom line, I appreciate that so we can move on.
Okay, sorry. The point I'm making is that the environmental conditions in that case are not the same. Therefore, we need to recognize that. But I also recognize the importance of the historical control because they give us a background of knowledge for that species of animal.
Exactly, and I think it's a question of weighting that is going to be variable from one person to the other. Dr. Adler, you'd like to respond?
So you succinctly captured it, Dr. Eaton, but separately offline, you and I, Dr. Lin, can have a discussion about the microbiome and what unknown effects it probably has on a lot of things, including how we even think, you and me.
That's a separate issue.
We do not want to go into the microbiome here. Okay, NTP staff respond?
Thank you, Dr. Adler, for your comments. First, I'd like to say I greatly appreciate your distinction about this being a hazard identification study. I think a lot of people over the years have kind of lost sight of that, of our goal. And to answer your question, the FDA would be the regulatory agency responsible in this case for doing a risk assessment. And although this is a hazard ID study, hazard ID studies are used for the risk assessment. And I think I mentioned before, I think the difficulty here is the way that the regulation is written based on a very localized effect versus whole body exposure. So I don't envy the FDA's position of having to answer this question. You brought up about the separation of doses, and I think we've had a lot of discussion about the selection of doses and the separation of doses, and we'll make sure that we more appropriately reflect this in the report to be more clear about that, so we can add in additional information regarding that. Again, we've had a lot of discussion about the historical controls, so just like the nonlinearity, I won't beat that horse, but basically what I'm hearing is, I think that I'm hearing is that a lot of people want us to be a little more forthcoming in the report or bring that forward a little bit about the issues surrounding the historical controls and why they may not necessarily be as appropriate in this study as they might be in other studies, and we'll take that under advisement and make sure that the report reflects this. Let's see. We talked yesterday a little bit about this decision-making rubric, and although that would be really nice and might make our jobs a lot easier, it's not necessarily fully appropriate. I think Dr. Blystow mentioned yesterday that we take these things on a case-by-case basis because a lot of these studies have different aspects and different kinds of responses, and so I don't necessarily fully agree that a decision-making rubric, one-size-fits-all, would be fully appropriate, but maybe we can make, as you mentioned, maybe we can make it more clear in the report about specifically for each of these indications exactly why this was done and why it was not done. And this kind of goes back, I think you had mentioned something a little bit about the nonlinearity, and again, I'll just reiterate that it wasn't only necessarily that we saw this at a certain lower exposure, but also it was taken into consideration the robustness of the effect. If the incidence was either below, did not exceed the historical control levels, or how much higher that was, and so again, this is obviously something that we need to address more in the report. I think you made a really good point. I think you made it yesterday too about the temperature being done during the day, not at night. I think this is an extremely valid point. And as we move forward and look at follow-up studies, I think I mentioned either on the first day or the second day that we're considering using different technology for collecting data for temperature. And these data loggers that we plan on using will actually record the temperature and not transmit it in real time, but just hold onto that data, so we'll be able to get information during exposures, which would include at night, during the day. So that will hopefully fill in that gap that the previous studies left open. As far as biomarkers are concerned, I think that's a great idea. I'm not sure I know of any off the top of my head, but that's something that we could definitely look into. I think that again, if we can find some biomarkers for exposure or for response, that would be good. As far as target organs are concerned, in this study, for the rat study, really the only positive finding was in the heart. So I think we were pretty clear that the heart was the target organ, but we can again make sure that that's clear in the report. And I know there's a lot of discussion around reorganizing and kind of presenting all of the equivocal data in a much more digestible and user-friendly form to be able to make those comparisons between males, females, and modulations. So I think that might help clarify some of this issue of identifying target organs.
Dr. Booker wants a comment.
So what Michael just said about the equivocals, of course, is dependent upon the votes and the discussion that you have during the rest of this meeting. So we're certainly going to take those recommendations into consideration.
That's great. And I definitely, I just wanted to echo your comments about the heart and about the mechanism. This was something that obviously came up as a bit of a surprise to us. I, for one, didn't expect that the heart would be a target organ. And so as we move forward and looking at additional studies, now we'll obviously be looking at the heart, and then other people obviously who are looking at this in this field. I think we've identified the heart, and hopefully more research will be done to elucidate why the mechanism behind why we're seeing what we're seeing, both for the cardiomyopathy as well as the neoplasms. I'll let Dr. Sesta answer your question.
Mark Sesta. Just in response to your question about the spatial association between the, well, some of the, more than the heart, but specifically you mentioned the right ventricular cardiomyopathy and the Schwann cell, proliferative Schwann cell lesions. We can put that into the report. And the other spatial associations that you and others have mentioned also will make sure those are clear in the report. Or, yes, or the lack there.
Thank you. Any other comments? Yes, Susan.
One very quick request with regard to the temperature to also include, and was brought up by a member in the audience as well, to emphasize that this was subcutaneous, the readings, because we don't necessarily know how they correlate to specific organs or core body temperature.
Right, yeah, and I think we had discussed that a little bit on the first day, and I think I had mentioned that we didn't actually look at whether or not this subcutaneous temperature itself was matched up with core body temperature, but that the vendor has done extensive work in that. And so maybe we can include some of the references to that work, but again, it's a good point that that is the case.
Dr. Adler.
Sorry, I should have made this point earlier. Regarding dose rationale, the doses were changed from the 28-day study to the 2-year study in both mice and rats. And you explained the thinking behind that yesterday and today. So that also should be reflected in the report.
Thank you. Any other comments? Yes.
Just really briefly, just considering the audience for this report, I think Dr. Adler's point about the hazard identification is really important and perhaps should be included even in the abstract.
Dr. Deacon-Boyd, did you have a comment?
Okay. Yeah, I mean, I wanted to offer this comment before we move into what I expect will be the second part when you allow us to get some lunch. I think that we're using, and we have to be very careful about this, I think that throughout this session we've been using overly liberally the expression dose. Watts per kilogram is not dose, is intensity of irradiation. It means like a 3 watt per kilogram, it's 3 joules being dispensed per kilogram of body weight. I think that a better way to express the dose would be to integrate that with time, with the 9 hours of exposure, and express it in joule per kilogram. That would be truly a dose. And so I think that correcting this in the report is probably a crucial element. Thank you.
Thank you for that comment. Okay, Dr. Cox.
As I said before, it is almost all said. And so I want not to repeat. I agree in particular with the statements concerning the study design and the conduct of the study. I consider it plausible for this specific task, and highly sophisticated from my point of view, because now I understand much more than before, and that was good. And I also think that the documentation of data with the improvements we discussed here and the narrative and the tables that reflect the conduct of the studies are appropriate and give a good overview of findings and their potential relation to the exposure scenario. So I did like that to read. Also, what information should be added? I think also this was said before, that the rationale, in the abstract, the rationale why the frequency was used for mouse and rats are different should be added, and I think that is very important, because this causes some confusion in the first moment, or did at least with me. And then I had some further editorial comments. I want not to edit, but you have everything. But I wanted to emphasize one point that is I feel is very important, and that is for me the considerations with respect to the brain tumors and the hyperplasia that was found. I think for the time being, when we do not have all the special examinations, I would like to see immunohistochemistry, more kind of evaluations on that, because when we add hyperplasia and tumors, what I normally never do, because they may have really different genetic backgrounds, then we would get more confidence in our decision that these brain tumors are indeed relevant. And this is, for me, a very crucial point. And I really would appreciate that there is a kind of glossar about the used terms in the report that explains more why that term was used. And what I've seen with the density, the difference of densities, that is for me not the crucial point for being hyperplasia or, let me say, tumor. When you look to the cell morphology and you see the cells, they are very, very similar. And this is make me uncertain to accept the term hyperplasia. And I think that was the most important thing. And one thing, what I thought is also important for the later evaluation, whether this is some evidence or equivocal evidence, is with respect to the low survival rate of the controls. I think we also have to think about if we have a zero value, and it is not a zero value out of the same duration of the study controls, and compared to experimental groups, it is very difficult to make that kind of judgment. Okay, I think that's all.
Thank you. Dr. Buchert?
So I would just, Dr. Blystone yesterday talked about the fact that we do survival adjustment in our statistical evaluations, and Keith is more than welcome to expand on this, but I think that to the extent possible, we are taking into consideration the survival differences in the statistical assessments.
And I think I would just add to that too that we provided information in the partial findings report for the heart tumors, and that data is available publicly. The schwannomas were occurring earlier than in the study, and so at least for the schwannomas, we don't believe that the survival in the controls would have any effect. If you look at the gliomas, it seems like those were more late occurring, and you could see for individual animals when that first occurrence was observed. But it seems like that was perhaps a later breaking tumor than the schwannomas.
And that's probably a place where it's useful to talk about time to tumor response as well. Other responses? Dr. Sesta?
Just with regard to the issue of the glial cell hyperplasia, we had these reviewed quite extensively, and there were a few pathologists who shared your point of view on that, but the majority of them did feel that glial cell hyperplasia was an appropriate diagnosis for those. And we will make it more clear in the report why that was so, what the logic was behind that. And as far as the immunohistochemistry, to further characterize those, I agree that would be a really good thing to do, and hopefully in the future we can go ahead and do that.
Any other comments or questions relating to Dr. Kaufman's comments? Thank you. If not, Ms. Pant, we will turn to you as our last presentation focused on the mutagenicity studies. Thank you.
I'll be quick. And in my case, the good thing is the comments I made yesterday, they were for overall COMET assay in both mice and rats. And today I'll talk a little bit about the rat assay. And so we saw hippocampus positive, and it's clearly positive. Whereas in frontal cortex, we have a trend, but it's not positive. And we say that it's not positive because we have variability there. So we have 6 in sham control, 6 in low dose, 9.5 in mid, and 12 I think almost 13 in the high dose. And so I was wondering, could we not have done some transformation of data or do non-parametric statistics? I think this looks positive. I mean, it's almost double. But anyway, and another point I have is in liver, there is such variability. The other organs, you probably didn't have any historical data. However, liver, you would have historical data in the system. And the thing is, initially, when they scored just 100 cells, they have the sham control value 13.81. And in the same sham control, we have 34% clouds, meaning 1/3 of the cells had more than 90% damage. That's huge. So could it have been because these samples were shipped? And the thing is, in mice, there wasn't that much variation, whereas in rats, especially in liver, I see there's a big difference. And even in low dose, you have almost 69% clouds. But then mid and high dose, those ghosts or clouds are less. So usually in liver, we have the ghosts around 1%. And the vehicle control range usually for liver is anywhere from 0.05 to 2. Whereas here we have huge range. And then we scored 150 cells. So they would have scored the backup slides. They would have stained the backup slides. It's same animal, and slides would have been prepared at same time, but then the scoring was done later on, and they scored 100. And so here, the vehicle control is 26% percentile DNA. That's huge. And at the same time, clouds, which we had seen 34% with 100 cells, now we see only 1.73%. So I was wondering if these slides were coded, because in COMET cells, it's all automated scoring. So everything is usually blinded, and then we score them. And or could it have been because these were shipped? There aren't that many publications for shipping these suspensions. And actually, we have also done some work, but in some organs it works fine, but not in others. I think the publications that I have read, it's same there too, that not all organs work well when the cells are shipped. That's all. Thank you.
Thank you. Dr. Witt? Sorry.
It's Ms. Witt. All excellent comments and all things that we have noted and tried to understand. Your comment with regard to the frontal cortex in the CDMA exposed male rats, it sure is statistically close to significance. We didn't have that one pairwise value pop over. It is due to the amount of variation among the animals that just makes it a little bit harder for the statistics to capture the response with regards to parametric and non-parametric. We did use those methods. So, go ahead. Do you have a comment on that before I go on to the other?
Sure. So we chose this. We first tested the variance to test for equal variance between groups, and then chose. So yeah. So we chose the test based on Levine's.
Yeah. And certainly it is close. There's definitely a biological pattern there in response. Yeah, almost, yeah. We have a number of those that are almost positive. With regard to the liver, you are absolutely right. We have got high values in the liver. One point of clarification is when we went back and rescored, we used the same slides. So they were the same slides. They were not backup slides.
Oh, so
Yeah.
in the same slide, they got the result.
Use your mic. Miss.
Yeah. The difference is in how they went about the scoring because in the original 100-cell scoring, the scorer was very conservative in what they actually clicked on with the software to evaluate percent tail DNA and visually eliminated cells that appeared to be hedgehogs, in the opinion of the scorer. And we noted high, in some of the tissues, high hedgehog values, but truncation of the percent DNA damage values to around 65%, which seemed odd, that there should have been values between, say, 65 and 90% or something. So when they went back, I requested that since they were scoring 150 cells, that they should click on every single cell, regardless of what they felt it appeared to be visually, and see if the software was indeed capable of evaluating the percent tail DNA. So you'll see in the rat samples, the 150 cell samples versus 100 cell, that yes, indeed, the number of hedgehogs declined because many of those cells were now moved into the actual percent tail DNA that was calculated for the particular animal. Because they were captured, they were able to evaluate that. So we had higher levels, we had a broader range. We captured a broader range of damage when we reevaluated the tissues, scoring as many cells as the software was actually capable of scoring. And then those that could not be scored, that were truly goat cells or hedgehogs, were eliminated and just tabulated separately. And with regards to the shipping, that is a good point. We have done experiments in the past when we first began to routinely freeze tissues because we were getting them from a remote laboratory oftentimes. Liver was not one of the cells that, or the cell types that we saw a problem in. You do get an elevation in damage when you freeze tissues, but usually everything moves up relevant to the control. But you're absolutely right. It is a high level of damage, and we don't have an explanation for that.
Thank you.
Did I answer all your questions?
Any other comments from anyone? If not, Dr. Klein?
I'm sorry, but just a couple of points relative to the COMET assay. I looked at the OECD method, and it describes different ways to disaggregate the cells. So which one was used, I think, would be helpful to have in the report, whether it was an enzymatic or a physical disaggregation of the cells. I would also ask the experts in this method, in the brain, I can think of 10 cell types that are in the hippocampus. And I would bet that there's a survival or a intactness gradient among them. There are some that make it all the way through the disaggregation into the COMET assay and some that break up. So if you have an opinion about whether, say, the microglia or the neurons, endothelial cells or another cell type would be most likely to actually make it to the slide, I'd love to know that.
In response to the method of disaggregation in the Appendix E, where we detail the methods that were used in the COMET assay, we do mention mincing. What we did was about a 15 to 20 second rapid mincing of the tissue in the microfuge tube, and then cap it and freeze it. And so the single cell suspension is created that way, and then when the sample is thawed, that single cell suspension is then used to create the slides. So that is detailed in there. We did not use enzymatic disaggregation. And your other question with regard to the cells in the brain tissues that were the source of the DNA damage studies that we did, I don't have an answer to that. We just get a small piece of tissue, like maybe 3 by 4 millimeters, and it's just rapidly minced and put in the tube. So I don't know that there's a way to identify the cells, the cell type.
Thank you.
Ms. Pam? Go ahead.
Yeah, I just wanted to say, and once you make single cell suspension and you make these slides, and finally when you read the slide, you cannot tell. I mean, it is a mixture of all different types of cells, but there's no way of saying, because the cells have been lysed, and all the nuclei look same. And for OECD method, you see, when the slides are prepared, at that time we prepare slides in such a way that each screen, because this is all automated scoring, in each screen we have only 7 or 8 cells. So you are supposed to score all of them, and then go to next screen and next screen. But sometimes when the slide is crowded, and that's when they start to pick and choose. And that's when the intention is kind of go for the cell which has bigger comet tail. Thank you.
Okay, thank you. It is now almost 10 after 1, so I suggest that the good news is the crowd should be less. We will get through. Let's try to reconvene in here at 10 minutes to 2, which gives us a little more than a half an hour.